Hello my dear students, I welcome you to this amazing channel of PhysicsWallah English. So guys, this is the third lecture in the Champions-JEE crash course, and today we'll be doing quadratic equation. If we talk about importance of this chapter, let's not go into importance because this is like the fundamental thing. There are 4 fundamental chapters which is going to be used everywhere, right? Like quadratic, you will see it in straight line, you will see it in any chapter of coordinate geometry, you will see it in binomial, in trigonometry, in sequence series, everywhere, differentiation, integration, everywhere you are going to use concept of quadratic equation. So this should not be limited to this problem that what is the actual importance of this. There is so much of quadratic everywhere, be it class 11th, class 12th. Okay, so we are going to study all core concepts in detail. We'll be solving some previous year questions also, and we'll be doing at the end we'll be doing some graph related problems also. Okay, so starting with, I'll tell you what is the lecture flow, guys. First we'll see what is the quadratic equation, then what is the identity, the relation between roots coefficient, then nature of roots, then common roots, maximum values, location of roots, theory of equation, transformation of equation, and at the end we'll do some graph related problems also. So let's see what is a quadratic expression. And I don't think I need to invest much time here, right? Because you have done this in class 10th also. Right? A second degree polynomial, quadratic will be a second degree polynomial. So x square plus bx plus c, where a will be non-zero. If a becomes 0, it will become a linear equation if a is equal to 0. Fine. Now about roots and solution. See, like this word keeps confusing students, that how many roots are there, how many solutions are there. I'll give you an example and everything will be clear. First of all, this should be clear to everyone that if you're dealing with an nth degree polynomial, it is going to have n roots, right? Nth degree polynomial will have exactly n roots, but when it comes to solution, it will differ. It may not be always n. See, I'll give you a simple example. X square minus 3x plus 2 equal to 0, and x square plus 2x plus 1 equal to 0. Here you factorize x minus 1, x minus 2 equal to 0. You get x equal to 1 comma 2. Here this is x plus 1 whole square equal to 0, and you see x equal to minus 1. So since this is a second degree polynomial, it is always going to have 2 roots. So in both cases it has 2 roots. Like here roots are 1 and 2. Here also I'll say 2 roots. I'll say, sir, how is it 2? It is only minus 1. No, roots are 2. Nth degree polynomial, it is exactly having n roots. Here we have repeated roots, right? Here we have repeated roots. Like I'll write roots as minus 1 and minus 1 again, because this is a quadratic, this is a second degree polynomial. It is supposed to have 2 roots. So if one is minus 1, if you are getting only minus 1, the other one is also minus 1. This is called the condition of repeated roots. Okay, fine. In this case we have 2 solutions, but in this case we have only 1 solution, right? So basically we are counting solution as distinct roots. Here we have 2 distinct roots, 1 and 2, so we have 2 solutions. Here we have only minus 1 as the solution of this equation, so we have only 1 solution. I hope this difference between the word roots and solution is clear to you. Okay, no need to confuse. Nth degree polynomial always n roots, irrespective of real imaginary. If it is nth degree polynomial, it is going to have n roots. Solution may differ, because solution we are talking about the distinct values, real values of x or the variable you are dealing with. Okay, I hope it is clear. Fine. And guys, what is an identity? Okay, what is an identity? See, any polynomial of nth degree, if it is having n plus 1 roots, it will be called an identity. It will be true for any value of x. Then see, if you say that ax square plus bx plus c equal to 0, if it has 3 or more roots, right? 3 or more roots, then this will be condition of identity. Then this will become an identity, right? And the condition of identity is that every coefficient will be equal to 0. The condition will be, if it is identity, if you are saying that the quadratic expression has become an identity, then all the coefficient will be simultaneously 0. Very, very important thing here. If you are saying that it is an identity, every single coefficient will be equal to 0 simultaneously. It's not like that you made a equal to 0 and you left C something with other real value other than 0. No. Every single coefficient will be equal to 0 if you are saying that the equation is an identity. Okay, let's solve an example. Suppose question is something like this. Suppose p minus 1 into x square plus p square minus 3p plus 2 into x and plus p square minus 1 equal to 0 is having let's say 5 roots. Is having 5 roots, find p. Right? They're saying that find p. Now this is a quadratic equation. Obviously it cannot have 5 roots, but they're saying that it has 5. So this is not a quadratic. Now this has become an identity condition. So the equation is identity. So all the coefficient will be equal to 0. P minus 1 equal to 0. P square minus 3p plus 2 equal to 0. P square minus 1 0. So from here you get p equal to 1. From here you get p equal to 1 and 2 and 1 and minus 1. But guys, remember all the coefficient has to be 0 simultaneously. So we'll choose the common value. So out of all these three, what is the common value you see? P equal to 1. What is the common value? So P equal to 1 will be your answer. And I hope you are able to understand like how the identity thing is working. See, what happens that once you have made all coefficient equal to 0. See, once you have made all coefficient is 0, now this is like 0 into x square plus 0 into x plus 0. Now just look at this expression. Isn't it going to satisfy every single x? Right? Suppose if this is your fx, now you just think of any x, every f alpha is 0 for all alpha belonging to real. Every single value of alpha is going to satisfy. This is not just having going to 3. Every single value of x is going to satisfy it. Right? This is the condition which we know as identity. I hope this is clear. Fine. So let's move on. Now relation between roots and coefficient. So in class 10th also you must have heard of the Dharacharya rule. Like when you put x square bx plus c equal to 0 and you solve for x, you get these two values of x, minus b plus minus this, and the expression b square minus 4ac is known as discriminant. This b square minus 4ac thing is known as discriminant. Okay. So guys, moving on. Like we know that for a quadratic equation, if we have a quadratic equation, ax square plus bx plus c equal to 0. Okay. And if you are saying that alpha and beta are roots, if alpha and beta are roots, then obviously the sum of roots alpha plus beta is minus b by a. The product of roots is c by a. I don't think anyone is having any problem with this thing. Sum of roots minus b by a, product of roots c by a. Also there is one more result which I'd like to write here. The result is this. If I is saying that, suppose this is your fx. Suppose this expression is fx and you are saying that alpha is the root. So if alpha is root, then 100% f of alpha is going to be equal to 0. F of alpha will be equal to 0. If beta is the root, then f of beta will be also equal to 0. And we are going to use these information in many problems, guys. There are many questions in exam which are going to be related with this thing. You feel that this is so obvious that f alpha is 0, f beta is 0, but I'll show you that how exactly we are using this to shorten the calculation things in problems. Okay, so if alpha is 0, that means we have this a alpha square plus b alpha plus c equal to 0 and a beta square plus b into beta plus c equal to 0. These two will be some useful result while solving problems related to roots and coefficient. Fine then. Now if roots are known, then this is how you write a quadratic equation. Okay. If sum of roots and product of roots are known, this is how we write it. The quadratic equation is x square minus this is sum of roots and this is product of roots. Okay. So if we have information about sum of roots and product of roots, we can write that, we can frame the quadratic equation associated with it. Okay, then there is one more result which I'll write here, and extremely important. JEE Main 2021 had asked 4 to 5 questions on the direct result, and guys, I'm talking about Newton's formula. Okay, I'm talking about Newton's formula. Now what is it? See, if you have some fx as some quadratic expression, and let's write an equation also, like ax square plus bx plus c equal to 0. We have this quadratic equation, ax square plus bx plus c equal to 0, and there is an expression Pn which is alpha n plus beta to the power n, right? And this has roots. Roots are alpha and beta. Okay, a quadratic is known, roots are known. There is a quantity Pn which is alpha power n plus beta power n. Now for this Pn, we can write as relation here, which is a into Pn plus b into Pn minus 1 plus c into Pn minus 2 is always 0 for any natural value of n, natural number value of n which is greater than 2. This is known as Newton's formula, right? And what is this Pn? This Pn will be an alpha n power beta, and n minus 1 will be n minus 1 beta minus beta to the power n minus 1. You see, the difference is of 1, n minus 1, n minus 2. The difference in these three is of 1, and the coefficient, you see, a, b, c, you can relate with here. This x square, this instead of x square we are putting Pn, x, Pn minus 1, c, Pn minus 2. So this should not be difficult to remember. If you want to prove it, now this is also very simple. What you do, you write Pn, you write Pn minus 1, you write Pn minus 2, and start taking common this a, b, c from all of these. Like, try to make it of this form: a alpha square plus b n plus c, you will get it as 0. Okay, when you expand this, you are going to exactly have two expression, and this is going to be equal to 0, right? So I hope I am making things clear, guys. You can see when you expand this, there will be total 9 terms, and those 9 can be written as sum of these 3, like thrice of the same thing, like where it is alpha power n, like alpha square plus b alpha plus c, like that, it will be equal to 0. Okay, so you can prove this, and you can remember. You have to remember also. Definitely you have to remember it. Extremely useful result. Okay, fine. Let's solve. Okay, let's see some few more concepts. Talking about nature of roots, the most important funda which deals with like the entire this particular thing, nature of roots is decided by the discriminant. Discriminant is the main deal here. Okay, so let's form some cases here. So case 1, when discriminant for quadratic ax square plus bx plus c equal to 0, if discriminant is 0, then what will happen? If discriminant is 0, right? So see, you know that what x is equal to minus b plus minus root d divided by 2a. So if you make d equal to 0, if d is equal to 0, then x will be equal to minus b by 2a. X will have only one value, minus b by 2a. So what is it? This is the condition where your quadratic expression is a perfect square, right? So when d is equal to 0, so what things we can write? That the quadratic expression is a perfect square of a linear polynomial. This is the first thing. It will be perfect square of a linear polynomial. And also apart from perfect square, what else we can write? Guys? We have repeated roots. We have the condition of repeated roots, right? Because x is only equal to minus b by 2a. Obviously there has to be 2. So this means that we have a repeating condition here. X is equal to minus b by 2a. Fine. So quadratic expression is perfect square of linear polynomial. We have repeated roots, and obviously we can say that both roots are real, right? Or we can simply say that roots are real. Let's remove this word both. Roots are real and equal. This is what we can say. Roots are real and equal. So mainly you will see it like this, that the quadratic expression is a perfect square. It will be simply saying that quadratic expression is perfect square of a linear polynomial. So then you have to think of that d has to be equal to 0. For example, okay, let's see an example. Suppose we have some x square plus 2x plus 1 equal to 0. Now what is it? What is discriminant for it? D is b square minus 4ac, it is 0. What is it? This is perfect square. This is x plus 1 whole square equal to 0. This is what we are talking about. That if discriminant is 0, it will be perfect square of a linear polynomial. Clear? So I hope the funda is clear. Funda is clear. This was the first case when d is 0. Now there can be other cases also. Okay. So when d is positive. Now what all things can happen if d is positive? Obviously that roots will be real and distinct. Roots are real and distinct. What else about like apart from roots being real and distinct? There can be some other possibilities also. The first thing is this: if d is perfect square, okay, if d is perfect square and all the coefficient a, b, c belongs to rational number, then both roots will be rational. Both roots are going to be rational number. Very, very important funda here. Discriminant is perfect square, and guys, see many students, what they do, they ignore this thing, that ABC is rational. See, this is the most important factor here. If you don't have ABC rational given, this will not hold true. Okay, if ABC are rational and discriminant is perfect square, in that case only both roots will be, alpha and beta will be rational. And you can think yourself when you write it as minus b plus minus root d. Now that root d is some rational value. So rational plus rational upon rational, it is going to be something rational. Okay. So if you have this condition that both roots are rational, then d has to be perfect square. Discriminant has to be perfect square. Then one more condition we have, that if d is not perfect square, okay, if discriminant is not perfect square and again ABC are rational, all the coefficients are rational, then roots will be irrational. Roots will be irrational and in pair also. Both roots will become irrational and in pair. Like I'll show you, if alpha is something like a plus root b, then the other root beta will be a minus root b. And this time also, this is very, very important to understand that this is required. Again, if you don't have info about ABC being rational number, this will not hold true. And I can show you it with a simple example, that if coefficients, if ABC are not all rational, then we can have other combinations also. We can have one rational, one irrational. If you want this to be possible, if you want one root as a plus root b, the other root as a minus root b, if you want this pair to be possible, then this is the most important thing. Apart from d not being perfect square, all coefficient has to be rational. Like see, if I multiply x minus 1 into x minus root 2 equal to 0. Now what do you see here? If you open this quadratic, this will be something x square minus 1 plus root 2x plus root 2 equal to 0. Now guys, see here, discriminant will be obviously not a perfect square. Apart from that, you can see we have irrational and rational both coefficients here. So we don't have any pair possible here. Why don't we have any pair? Because the coefficients are rational as well as irrational. So I hope I'm making my point clear. In the other hand, if we have roots as irrational pair, you will have rational coefficient. See, x minus root 2 minus 1 into x minus, okay, so one root is root 2 plus, let's say root 2 plus 1, so the other root will be 1 minus root 2 equal to 0. You see, when you multiply this, what do you get? X square minus, what is this? This will be a plus b. So when you add these two, root will cancel out. What will happen? This will be 2x. And when you take product, root 2 plus 1 and 1 minus root 2, what is it? 1 minus 2 minus 1 equal to 0. You see, you have what type of things you have here? You have rational coefficients. This is what I wanted to show here. Okay. So I hope I am making these points clear. That if you are saying that roots are irrational pair, the most important funda will be looking for the coefficients ABC. If the problem it is given that they are rational, go for it. If it is not given irrational, then you cannot come to any conclusion by D having something not equal to perfect square. Okay, if D is perfect square and being rational, coefficient being rational, we have this thing true. Fine. So this is what the most important results we have in D greater than 0. And if D is less than 0, okay, if discriminant is less than 0, now in that case we'll have imaginary roots, right? Because inside root will be having something negative, so we'll have imaginary roots. We'll have imaginary roots, okay, and roots will be in conjugate pair. Roots in conjugate pair. Okay, and again this is also important to understand that all ABC will be real number. We are writing these conditions only for ABC real. If coefficients are not mentioned real, then this will also fail. The roots will be in conjugate pair. The roots will be imaginary and conjugate pair only if roots coefficients are real. So if one root is something a plus iota b, the conjugate, the other root beta will be conjugate of it. Okay, so I hope all these points are clear to you. Moving on, guys, moving on. Starting with problems, let's solve questions now. Whatever nature of root thing, whatever sum of whatever the relation between roots and coefficient we have seen, we'll see problems on this. And the majority of the problems from core quadratic things, like core quadratic by mean I that the problem which is directly solved from roots and coefficient are from this section. Okay, so like in 2021 I can say that if there are, let's say if there are let's say 50 questions are there, out of 50, 35 questions will be from this section. Out of 50, 35 questions will be the section which is only with relation between roots and coefficient and nature of roots. So let's solve questions. So for what value of k the expression will be a perfect square? How simple is this? D should be equal to 0. So just put D equal to 0. Discriminant 0. So D is b square equal to 4ac. So 4 times this is 4 minus k multiplied by 8k plus 1. Just simply solve it. Put D equal to 0 and simplify it. So this 4 will cancel out. This will be k square plus 4k plus 4 is equal to, how much is this? This is 32k. And plus 4 minus 8k square minus k. So this will be 9k square and 32, and this is 31k. So minus 27k equal to 0. So k is either 0 or 3. This is the result. K will be either 0 or 3. So what did we use? D equal to 0. Discriminant is 0 because it is a perfect square. Fine. Let's solve next, guys. So what is the question here? Show that the expression will be a perfect square. If it is a perfect square, if the given expression is a perfect square, in that case, what we have to do? This is a quadratic expression. So if a quadratic expression perfect square, its discriminant is 0, put D equal to 0. When you put D equal to 0, what do you say? 4 times a plus b plus c whole square equal to that. So you will receive this a square b square c square minus ab minus bc minus c equal to 0. When you solve it, this is what you are going to do. And this is the result which I have written 10 times in previous lectures also. Because so many times you are going to come across this. And we know that this can be written as half of a minus b square plus b minus c square plus c minus a square equal to 0. And if sum of squares equal to 0, that means each bracket will be equal to 0. You will put this equal to 0, this equal to 0, this equal to 0. So simultaneously ABC will be all 0. Right? Okay. Let's solve next. So if one root of the equation is root 3 plus 2, then another root. You see, this is the type of question I was talking about, that it will be very deceptive if you don't get to the core concept here. You see, what is it? What is it saying? That lambda is a real number. This coefficient lambda is a real number, and we already have one irrational coefficient, root 3. So the funda which you might have this in mind, ki sir, one root is root 3 plus 2, other root will be 2 minus root 3. No, look at the coefficient, they are not rational. So that funda will fail, and you have to deal with the most basic thing, which is sum of roots or product of roots. Go for it. So alpha plus beta will be equal to how much, guys? This is root 3. So let's say alpha is root 3 plus 2. So if alpha is root 3 plus 2 plus beta will be equal to root 3, beta will be equal to minus 2. So the other root is minus 2, right? And some of you will feel that it is a 2 minus root 3. No. Why? Because the coefficients are not mentioned to be rational. Cool. Let's solve next. So this question is multiple correct. We can have multiple answer correct. This question I have taken only to show you that f alpha equal to 0, f beta equal to 0, how those two results solve help us in solving like calculative problems. You see, now if you don't have common sense, what you'll do, or if you have like very less of common sense, what you'll do, you just simply multiply it here, and you will say, sir, question was very difficult. But that is not why this question is given to you. This question is not given to you to just to multiply and solve. No, there is a result which has to be used here. You are not a class 10th student. Okay, in class 10th you can go for that. You can just simply take LCM and multiply, because in class 10th you don't have anything to do with your life. Okay, but in 11th your time is valuable, so you will not be doing that. So what exactly we have to do? We have to take help of f alpha equal to 0. Now what exactly that means? See, alpha beta are roots. So can I say for this equation, like alpha square plus 3 alpha plus 1 will be equal to 0, and beta square plus 3 beta plus 1 will be 0, right? Because alpha beta are roots. So you see, in the options it is 3 alpha plus 1 and 3 beta plus 1, and we can have 3 alpha plus 1, 3 beta plus 1 in our expression also. There is some relation. So what is that 3 alpha plus 1? It is minus alpha square. What is that 3 beta plus 1? Minus beta square. So let's use it. We can write here, this will be equal to alpha square divided by alpha square, beta square divided by beta square. So it is correct. This will be minus 2. Correct. You see, if you had taken LCM, how lengthy it would have been gone, right? How many steps you would have taken if you don't go by this logic. Understood? There is some always correlation if you have similar looking expression in the option and whatever they have given to you. Okay, so I hope I have made it clear. So this was for the C option. Now for D option also it looks calculative, but in the similar way it is not. Using f alpha equal to 0, f beta equal to 0, you can reduce steps of calculation. What do I mean? You can write this as alpha square divided by 1 plus beta square plus 2 beta. The second one will be beta square divided by 1 plus alpha square plus 2 alpha, right? Now 1 plus beta square and 1 plus alpha square can be also reduced in some simpler forms. Like in the same expression, can I say that 1 plus alpha square is minus 3 alpha and 1 plus beta square is minus 3 beta, right? So we can replace it here. So 1 plus beta square will get replaced by minus 3 beta plus 2 beta, and this will be equal to beta square, 1 plus alpha square will be minus 3 alpha plus 2 alpha. You see how question has become, this is so easy now. Alpha square divided by beta plus beta square divided by alpha, and this type of thing you have solved in your class 10th also. Now this is alpha cube, beta cube, you know how to factorize. You have everything in the terms of alpha plus beta, alpha into beta, substitute and solve. But I hope you got my point, that in quadratic, in 11th, we don't go for always calculation first. Try to see any correlation. How did I find out that correlation? 1 plus beta square, I do have 1 plus alpha square, 1 plus beta square. Fine. Let's solve next, guys. Okay. What is say? Let one root of the equation is square of the other root. So one root of the equation is square of the other root. So what we can write? That if one root is alpha, the other root will be alpha square, and this is equal to minus L. Right. Now this is nothing has been said about x. Right, about roots, nothing has been said. So this is one result. What is the other result? What will be the other result? If see, okay, alpha into alpha square will be equal to what? It will be m. So alpha will be equal to m power 1 by 3. Right, alpha will be equal to m power 1 by 3. Now we can replace it here. So this is m power 1 by 3 plus m power 1 by 3 square will be equal to minus L. Now guys, if you are aware of the omega thing, see this question actually it requires some information of complex number also. You can use it, we can solve it without that also, but it will take so much of calculation because then you have to get m to the power something integer. You will do cubic, you will cube both the sides, it will take so long. So this question actually it involves some knowledge of complex number also. And what is that? You see, you have heard of omega, like omega plus omega square is equal to minus 1, right? So L can be equal to 1 also. That is 1 for sure. Omega plus omega square is minus 1, so L will be equal to 1. Now you know that L is equal to 1. This here, since m is real, so let's say m power 1 by 3 something t, where t will be real. So if t is real, this will be t square plus t, and this will be plus L equal to 0. So if t is real, then discriminant will be positive. So you will write d is greater than equal to 0. So b square 4L will have L from minus infinity to 1 upon 4. That is right. So if t is real, we got it, right? Because d has to be greater than 0. So and since alpha, we have not any specific relation here for alpha, right? Alpha can be imaginary also. If alpha was given purely real, then this would be incorrect. We will not go for omega and omega square. So answer will be only minus infinity to 1 upon 4. But nothing has been specified about alpha. So we'll have to consider that alpha may be some imaginary also. In that case, our answer will be minus infinity to 1 by 4 union 1. Why this 1 for? For this combination. If x is omega, this will be true. Fine. So I hope this is clear to you. Moving on, guys. So in this question, what is given? See, a alpha and beta are the distinct roots of the equation. Now this is from 2021. Okay. And this is not 3, guys. I think there is some printing error here. This is only 5. This is 5 to the power 1 by 2. I hope so. This is the result, 5 to the power 1 by 2. So we have to find out value of alpha power 8 plus beta power 8. Now alpha power 8 plus beta power 8, obviously it looks like too tough to calculate. But what you have to see, this alpha power 8 plus beta power 8, guys, can I say that alpha plus beta square is equal to alpha square plus beta square plus 2 alpha beta. Now alpha plus beta is how much? 5 to the power 1 upon 4. Alpha plus beta is 5 to the power 1 upon 4. So if I replace 5 to the power 1 by 4 here, it will become root 5. So root 5 is equal to alpha square plus beta square plus 2 alpha beta. What is 2 alpha beta? 2 alpha beta. So alpha into beta is how much? 5 to the power 1 by 2. So this will be 2 root 5. Again, right? This will be 2 alpha beta. Alpha into beta we know it is equal to 5 to the power 1 by 2, which is root 5. You substitute it here. So from here, what do you see? That alpha square plus beta square comes out to be equal to minus root 5. Fine. Now square it again. So alpha square plus beta square whole square will be equal to alpha power 4 plus beta power 4 plus twice of alpha square beta square. So this is known. This will be equal to 5 equal to this alpha power 4 plus beta power 4 and plus what is alpha into beta? Alpha into beta is 5. Alpha into beta is how much? 5. So root 5, sorry, root 5. So this is alpha into square, so this will become 10. So again we have alpha power beta power 4 equal to minus 5. We got this. Again you square it. So if you square this time now, so alpha power 8 plus beta power 8 plus twice of alpha beta to the power 4 will be equal to 25. Right? So you want this. So what is it? Alpha power 8 plus beta power 8 plus this is alpha plus alpha into beta is 5 power 1 by 2. So 5 power 1 by 2, this will be 5 square, this will be 50, 25. So the answer will be equal to minus 25. This is your answer. Fine. This is how you are supposed to go through it. You start, see, if it is about even power, this is how the logic will go. Okay, in the case of even power, the problem will be very simple. Fine. The actual question was something else. This is not the exact 2021 problem. The actual problem is something else. In that, alpha plus beta, alpha square beta square comes out to be 0. So the calculation is even easier, guys. Okay. But I hope you are understanding the proper logic behind it. Let's solve next. So let alpha and beta be two real numbers such that alpha plus beta is 1 and alpha into beta is minus 1, right? Alpha plus beta and alpha into beta is given, so we can write that quadratic. What is that quadratic? It is x square minus alpha plus beta x plus alpha into beta equal to 0. If roots are known, this is how we write that quadratic. So the quadratic is x square alpha plus beta is 1, so minus x alpha into beta is minus 1, 0. This is the quadratic, right? So if you compare it with ax square plus bx plus c equal to 0, you know what is a, b and c. A is 1, b is minus 1, c is minus 1. Okay. Now you see that pn plus 1. Pn is alpha power n beta power n. Whenever you see alpha power n plus beta power n, your mind should should be able to recall that Newton's formula. Okay. So pn is known, pn plus 1 is given, and pn is asking, pn has been asked, and pn minus 1. You see, you have 3 consecutive such terms, and that is what we need in case of Newton's formula. Like what I can say here, using Newton's result, I can write, using Newton's formula, I can write a into pn plus 1, right? Whole square, not whole square, a into pn plus 1. Then next one will be plus b into pn, c into pn minus 1 will be 0. Using Newton's formula, you see pn plus 1 is given. How much is 29? A is 1. So 1 into 29 plus b is minus 1. What is pn? Pn is required. Pn is required. So plus pn, and c is also known, minus 1. Pn minus 1 is how much? 11. So minus 1 into 11 equal to 0. What is, guys, pn? Pn is 18. What will be pn square? It will be 324. But if you don't have idea about Newton's formula, you can still solve. See, it's not like that. If you don't know this formula, you will not solve. But it has saved at least 4 to 5 minutes of yours if you are aware of the result. How much time it is going to take? Hardly 20 seconds or maybe 10 seconds, right? Because here I am explaining too much. That is why it is taking time. Otherwise, within 20 seconds you will kill it. 10 seconds you will kill it, right? Again, this is question from 2021. This is question from 2021. Moving on, guys. Alpha and beta with the roots. Alpha n given. Find value of this. Almost similar problem, and like these types of problem has been repeated so many times here. This was repeated in JEE Advanced. This type of problem was given in JEE Mains 4 to 5 times. 4 to 5 times. Okay. So you have to understand the method of solving this problem. See what it says, that an is alpha n minus beta n, and we have to find out. Fine. So a10 minus 2a8. What is a10? a10 will be alpha power 10 plus beta power 10, right? Minus, there is a negative sign there. Fine. There is a negative sign. So let's do one thing. Let's write the numerator. Let's solve the numerator part, guys. So what is it? a10 will be alpha power 10 plus beta minus beta power 10. I'm writing again and again plus. I'm missing Newton so much. Alpha power 10 minus beta power 10 minus Alpha power 8 minus beta power 8. Okay. This is the numerator part. Fine. Since alpha and beta are roots, guys, so we definitely have this information also with us, that alpha square minus 6 alpha minus 2 is 0, right? And we have beta square minus 6 beta minus 2 also equal to 0. So with these two, can I write that alpha square minus 2 will be always equal to 6 alpha. Similarly, beta square minus 2 will be equal to 6 beta. Alpha square minus 2 6 alpha, beta square minus 2 6 beta. Now just look at here. Alpha power 10 minus 2 alpha power 8. So if I take alpha power 8 common from here, so this will become alpha square minus 2. Similarly, take beta power 8 common, beta square minus 2. Right, I have taken alpha power 8 and beta power 8 common. Now I can replace alpha square minus 2 with 6 alpha. So can I write this is alpha power 8 into 6 alpha minus beta power 8 into 6 beta. So this is 6 times alpha power 9 minus beta power 9. And what is this? This is A9, right? This is A9. Is it not A9? It is. So this is 6 times A9. So your numerator is 6A9, so 6 by 3, the answer will be 2. But again, what we have used? We have used F alpha is 0, F beta is 0. Such simple funda we have used here. So I hope you have understood it, guys. If not, pause the video, solve it 10 times. But do be clear with every single step here. Okay, moving on. Again, you see same problem. Now this is exact Newton's formula, guys. There is not even a doubt about it. This is an power bn. This is quadratic 5 6 minus 2. So what you have to look for? The exact coefficient with decreasing of that pn. Like there will be 3 consecutive in decreasing order. So let's see which follows coefficients also. 5 6 minus 2. You can clearly see this D option. 5s6 plus 6s5 minus 2s6 equal to 0. This is correct because we have 5 6 minus 2 and then we have decreasing s6 s5. So I think there is some error, guys. There is some error. 5 s6 6 s5 and it should be 2 s4, right? Otherwise no option will be correct. This was correct option. This is 4, guys. This is 4, right? This is 4. So 5 6 5 4 D will be correct. Just the one correction here. This was 2s4. Okay, direct use of Newton's result. Here 5 8 5 4 no, 8 5 4 no, 6 5 6 no, 6 5 4. The difference is of 1 in all the 3. Right? They are 3 consecutive terms. Let's solve next. Now what the question says? Alpha and beta are the roots, okay, gamma delta roots of this equation. So for x square minus 3x plus p equal to 0, roots are alpha beta. Fine. Then gamma and delta are roots of the other equation. So x square minus 6x plus q equal to 0, roots are gamma and delta. What else is being given? That alpha beta gamma delta are what? They are in GP. Fine. They are in GP. So if they are in GP, so guys, what I am going to do now, I am going to simplify a bit. I am going to rewrite alpha r, and gamma delta is alpha r square alpha r cube, because we'll be having less variables to deal with. So I replace them with these alpha r square alpha r cube. Now what is next? They want us to find out 2q plus p. Okay, this is what they want. They want what is value of 2q plus p divided by 2q minus p. So if I take q common, so 2 plus p by q, 2 minus p by q. So basically we have to find out p by q. If p by q is known, our problem is over. Let's find out p by q. How to find? What is alpha plus alpha r? Right, what is alpha plus alpha r, guys? That is 3. And what is alpha r square plus alpha r cube? 6. Right? Sum of roots. Alpha alpha r are roots of the first equation. Alpha r square alpha r cube roots of second equation. Now divide them. So if you divide, right, you divide equation 2 by 1. So we get r square common. So r square will be equal to what? 6 by 3, 2. So we got value of r square. Okay. Now coming to the product part. Alpha into alpha r is p and alpha r square into alpha r cube is q. Now if you divide them, guys, if you divide them, so what do you have? This is r power 5. So 1 upon r square becomes equal to p by q. And r square is known to 1 upon r square, sorry. This is r power 4, right? So r square is 2. So p by q will become equal to 1 by 4. So once we have p by q value, you can put it here. This is 2 plus 1 by 4 divided by 2 minus 1 by 4. What is it? This is 9, 7. 9 upon 7 will be your answer. Option A. Clear? So this is quite basic concept question here. And this is also from 2020, right? The problems you can see, most of these are PYQs and how easy they are being framed. The tough looking problems were direct result of Newton's formula. So in fact, there is nothing tough. There's nothing tough if we talk about the direct problems of quadratic concept in JEE mains. Fine. So let's keep solving. Now this question, see, alpha and beta are roots of the equation. Fine. Then the value of almost same thing we have to do. This time we have to go for some calculation also. Because we don't have, see, we don't have 1 minus alpha square term, 1 minus beta square term, so we cannot do anything about it. We have to get into some calculation, right? So alpha upon, but it is easier to deal with linear than quadratic. What we can do here to simplify, like to reduce our calculation to some extent, we can write that quadratic in terms of linear. Now what do I mean by that? See, if alpha is a root here, so 7 alpha square minus 3 alpha minus 2 equal to 0. So I can replace that. Alpha square is equal to 3 alpha plus 2 divided by 7. Right? Alpha square will be equal to 3 alpha plus 2 divided by 7. Or see, if you want to do only in terms of alpha, that is also not a problem. Let's directly solve it. Because the terms are not difficult to deal with. It's not like that we have some q power 4 power 5. We have simple quadratic expression. I think we can deal with that. This take LCM. Alpha minus alpha beta square plus beta minus beta alpha square divided by their product 1 minus alpha square plus beta square and plus alpha beta whole square. Look, just look here. Not a single term is there which you don't know how to calculate, right? It is direct results. This is alpha plus beta minus alpha into beta, alpha plus beta again, divide by 1 minus alpha plus beta whole square minus 2 alpha beta and plus alpha into beta whole square. Everything is in terms of alpha plus beta, alpha into beta. Replace the value and simplify it. There is no like not even one mole of brain we are using it here. Simple calculation. Fine. Let's solve next one. I think this is also pure calculation. Alpha and beta are two roots of the equation. Value of alpha cube by this, beta cube by this. Now you can see 3 and 5 1 by 8, 3 and 5 1 by 8. So it's better to take LCM, guys. Let's take LCM. So take LCM, it will be alpha power 5, beta power 5, 5 by 8, 5 by 8. So alpha into beta to the power 5 by 8. Now when you divide, what will be it? This will be beta power 5 by 8 will be gone. Alpha power 5 by 8 and this will be 3 by 8. So it will become alpha. You see, there we are making a fool of this problem. Alpha plus beta is minus b by a. 64 alpha into beta is 256, which is 256 to the power 5 by 8. And just simplify it. Write everything in the powers of 2. 64 is 2 power 6. 256 is 2 power 8. Right? So it will become 2 power 5. The answer is simply 2. The answer is 2. And this is also 2021 problem, right? This was asking 2020 or 2021. I don't know exactly here, but this is JEE main PYQ. Right? You can see the level. You can see the level, guys. It's not like that they are always going to give you questions from Newton's rule. No, they are going to give you such simple LCM type problems also. Okay, so let's keep solving. Next one. If alpha and beta are the roots of the equation, then beta is equal to, now this I can say it has some like touch of difficulty here, but not again difficult. 2x into 2x plus 1 is equal to 1. Beta is equal to, now we need to write beta in terms of alpha. So guys, this you multiply, this is 4x square plus 2x minus 1 equal to 0. Roots are alpha and beta, right? 4x square plus 2x minus 1 is, roots are alpha and beta. So, and one root is alpha and beta are known. Fine. So what is alpha plus beta? Alpha plus beta is minus b by 2a. So minus 1 by 2. Right? It is minus 1 by 2. If you multiply by 2 here, we have this relation that 2 alpha plus 2 beta, right? 2 alpha plus 2 beta is equal to minus 1. We have 2 alpha plus 2 beta equal to minus 1 here. What else we have, guys? What else we have? What else we have? We have that 4 alpha square, okay? We have 4 alpha square plus 2 alpha minus 1 equal to 0. 4 alpha square minus 2 alpha minus 1 equal to 0. I need beta from there, right? I need beta. So 4 alpha square, 2 alpha minus 1 equal to 0. So can I replace 2 alpha, like can I replace here 2 alpha with beta here? Can I write this is 4 alpha square plus 2 alpha will be 1 plus 2 beta, right? 2 alpha will be 1 plus 2 beta, or what else we can do here? One more thing we can do here is one more thing we can do here. See, this was fine. Alpha plus beta is minus b by 2a, so minus 1 by 2, right? This minus 1, no, this minus 1, let's replace it with 4 alpha square plus 2 alpha. This minus 1, I'm going to replace it with this. This will be 2 alpha plus 2 beta equal to 0. Now see, so 2 beta is equal to minus 4 alpha square minus 4 alpha. Got my point? I replace that minus 1 with 2 alpha plus 2 beta. When you put it here, 2 to 4 alpha. So 4 alpha square, this will be minus 4 alpha. So what is beta, guys, now? Beta will be equal to, if you take 2 common from there, so it will be minus 2 alpha square and minus 2 alpha. So if you take minus 2 alpha common, it will be alpha plus 1, right? So minus 2 alpha into alpha plus 1, the second option. And this is like slightly difficult, but not the advanced type. This is the trending JEE main level. Okay, like last few years, the questions have been slightly tricky, and not every question. Like say if you are in one session, if you have 8 papers, 2 of them will be full of tricky questions, right? Or almost like almost the other papers are of same level, easy level. But this also I don't consider difficult. You see, one replacement we had to do and we got it. Clear, guys? Let's solve next one. You see, I can sense Newton's formula here, because let alpha and beta roots equation this ak plus bk not true, where k is greater than, this is 1 here. Okay, so this question I'm not going to solve, I'm going to leave it up to you, because see, p1 and p2 are very easy to find out. What is p1? P1 is alpha plus beta, which is equal to 1. What is p2? P2 is alpha square plus beta square, that is alpha plus beta square minus 2 alpha beta. This is 1, alpha into beta is minus 1, so plus 2, 3. So P3 is also very simple to find out. P3 is alpha q plus beta q, which is equal to alpha plus beta whole cube minus 3 alpha beta into alpha plus beta, right? So alpha plus beta is minus plus 1, alpha into beta is minus 1, and alpha plus beta is again 1. So what is this? This is 4. You see, alpha plus beta is 1, P2 is 3, P3 is 4. After that, using Newton's formula, we can find out everything. No need to calculate, right? Say if you want to calculate P4, we have to go till only P5. So this is not difficult at all. You can calculate P4 and P5 now, right? What will be P4? If you write with P4, what is it? 1 into P4 minus 1 into P3 and minus P2 equal to 0. That's it. We have got P4. What is P4? P4 will be equal to P3 plus P2. P3 is 3, P2 is 4, P4 is 7. Similarly, we can find P5, P6, whatever they want, we can find out and we can solve it. Clear? And this is how the Newton's formula is. Like, even without Newton's formula also we can solve, but it is saving your 30 to 40 seconds of calculation, which matters most in exam, right? The time is the most valuable thing there. So you have to save it wherever from you can. Okay, moving to next question. Again, this is based on direct concept. The least positive value of alpha for which the equation has real roots. Okay, real roots for 2x square. What is the equation, guys? Let me write the equation again. This is 2x square plus a plus 10 into x, a plus 10 into x plus 33 by 2 minus 2a equal to 0. Has real roots and they want what is minimum value of a. So this is a simple quadratic given, and see this is what they do. Since the concept is very simple, they give some like a data which might go lengthy in calculation, right? Because they cannot make question difficult with the concept. There is nothing to think. Roots are real, so d greater than 0. So when you calculate d, they made it difficult with the values. No problem, we are pro at calculation. So b square is greater than 4ac. 4ac. So 4 into 2 into 33 by 2 minus 2a. Right? Roots are real. So b square, a plus 10 is greater than b square is greater than 4ac. So 4 into 2 into 33 by 2 minus 2a. Fine. Let's simplify it. So a square plus 100a plus, sorry, this will be 100 only. Let me correct it. A square plus 20a plus 100, and this is greater than this 2 will cancel out, so this is 4 into 3, so 132, right, minus this is 2 to 4, 16a, guys. A square 20a plus 100 is greater than 4, 2 will cancel out, minus 4a, and then again 1 4 is there, so 132 minus 16a. So what is going to be this? A square and plus 20 plus 16, 36a. 20 plus 16, 36a minus 32 is greater than 0. I hope my calculations are all correct, right? This is greater than 0. Now, can we factorize like 36, 32? Can we factorize? 36a minus 32. Let's find out. Let's find out, guys. This is 32. So can we factorize 32, 16 to 18? I don't think so, right? I don't think we can factorize, so we have to go for the Dharachar rule. Okay, so a will be equal to minus 36 plus minus b square 36 square minus 4ac. It will become 4 into 32 divided by 2a, right? So you will get two values of a from here. You will solve this inequality and you will get that value. Now 36 we can know this is 4 square into 9 square. So this is minus 18 plus minus. Now 36 square plus 4 into 32. So this is 4 square into 9 square plus 4 into 32 will be 4 into 4 into 8. So 4 square into 8. So guys, 4 will be out. 9 square is 81 plus 89. It will be root 89. Now root 89 we can approximate how much? Root 89 is like 9.2, right? 9.2 something like that. So minus 18 plus minus 9.2 something like that, divide by 2. So let it be something 4.5, right? So you have those values. Now they want least positive, okay, least positive value of alpha. So using calculation of that, those things you can find out, because you know that a here will be, a will belong to something minus infinity to something. Let's say a, then union b to infinity. So this b will be your answer when you solve it, this inequality. So I'm leaving calculation up to you. I'm leaving calculation up to you. This was direct problem. This was direct problem. When you solve it for A, this is what the interval you will get. Whatever value of B you will get, that will be the least possible positive, right? That A you are going to get negative. Fine. Moving on to next. The problem was simple. You just had to do simplification. The number of integral values of m for which the equation has no real root. Okay. This time we don't want any real root. So if they want no real root, D has to be less than 0. Okay, D has to be less than 0. What is this? B square. So 4 into like 1 plus 3m square is less than 4ac. So 4 into 1 plus m square, right? Multiplied by 1 plus 8m. Right? Number of integral values of m for which this equation has no real root. So we got this. Now 4 will cancel out. Simplify it. 9m square plus 6m plus 1 is less than 1 plus 8m, right? This is 1 plus m square, 1 plus 3m, 1 plus 8m. So this will be 1 plus m square, right? 1 plus, right, 1 plus m square, then plus 8m cube, and then anything else, plus 8m also. So clearly we have a cubic equation here. We have 8m cube. Okay. We have 8m cube, 8m, 9m, minus 8m square, and then minus 6m greater than 0. Right. 9m square you take it to RHS. This will be 8m cube, 8m square, 6m. 1 will cancel out, 8m cube, that's all. So we can take m common then again. Let's take 2m common. So 4m square minus 4m minus 3 is greater than 0, right? And what do we want? Integral values of m for which has no real root. So we need to simplify this and see how many integers are there in this range. So can we factorize? This is 4 into 3 minus 12. I think we can factorize. This is 4m square minus 6m plus 2m minus 3 greater than 0. So m into, so we take 2m common. So it will be 2m plus 1 into 2m minus 3, right? This is 2m minus 3. I hope it is correct. 2m if I take common, this is 2m minus 3 and 1, right? This is 4m and this is 4m minus 6m, right? Fine, greater than 0. So we have those values now. Critical points, m is minus 1 by 2, m is 0, and then 3 by 2. Plus minus plus minus. We want greater than 0, so we have two such intervals. Now the number of integrals, there will be so many of them, right? So you can see your answer from there. Again, there was no such hi-fi fundi here. What did they want? Has no real root, d less than 0. When you do d less than 0, you get a simple inequality in m. You solve the inequality, you get your result. That is all. That is all that you have to do here. Okay. So I hope these concepts are clear. Let's solve next one. Now what is the question here, guys? If one real root of the quadratic equation is cube of the other root, right? If alpha is equal to the cube of the other one, beta, let's say beta, like roots here will be alpha and alpha cube. Okay. One is cube of the other. These are the roots. Then the value of k is 1 is cube of the other one. So what is alpha power 4? What is product of roots? It is 256. So definitely alpha will be equal to 4, right? Plus minus 4, right? So the value of k is, now what is k? K is, I think I missed something, right? There is the 81 also in the numerator and the coefficient, guys. So let me solve it again, right? Product of roots, alpha and alpha cube. One root is cube of the other. So if one is alpha, other will be alpha cube. So alpha into alpha cube is equal to how much? This is 256 divided by 81. So alpha will be equal to 256 by 81 power 1 by 4. So what is that, guys? 256. This will be equal to 4 divided by 3 with plus minus sign. You can use plus minus sign because it is 1 upon 4. Fine. Then we need to find out k. So what is k? K is sum of roots. So alpha plus alpha cube is equal to minus k by 81. That's all. You solve it for alpha equal to 4 by 3 or minus 4 by 3, then you can check your answer. If alpha is 4 by 3, check for, you will check it. Check for alpha equal to 4 by 3 or minus 4 by 3. You have alpha value and that is all you need to do. Okay. I hope I am making these points clear. And obviously guys, see 81x square kx plus 256, the coefficients were given in such a way that the fourth power has become very simple to find out. Fine. So it's not like that most of the questions are going to be always calculative. It's not. The quadratic section is one of the easiest section in your paper. Easiest section in your paper, definitely. Fine. Like the questions of these type. Moving on to the funda again. So I'm leaving this question as a homework. The similar problem, right? The similar problem again, it is same 2a9. This is 2a8, guys, and this got repeated. See, this is in 2015, and the exactly same problem was asked in 2021. The question that we did, it was from 2021. So the question has been repeated, and the concept you can say it's similar. Fine. In advance, this question was there in JEE mains 3-4 times. So you can solve it. There's nothing new here. Now moving on to the next concept of common roots. See, when you say that the quadratics are having common roots, quadratic it is having two roots. So either there is one root common or we'll have two roots common. So we'll discuss both the condition by one. The condition when we say that only one common root is there. Now this is the difficult part, and also the most of the questions you are going to see from this section where we have only one common root. Okay, only one common. Now I'll explain the logic here. What you do, there is no formula, not a single formula you have to remember. Okay, just see that in case of only one root being common, how do we deal with those problems? Let's write two quadratics first. Let's say we have one quadratic, a1x square b1x plus c1 equal to 0. The second quadratic, a2x square plus b2x plus c2 equal to 0. Fine. The quadratic equations are given, and what else is given? That these two have one root in common. These two quadratics have one root in common. Okay. So assume, this is how you will always proceed. That assume alpha is common root. Right? Assume that alpha is common root. So if alpha is common root, then alpha is going to satisfy both the equations. Correct? Alpha will satisfy both the equations. So substitute. So alpha is going to satisfy both the equations. So a1 alpha square plus b1 alpha plus c1 will be equal to 0. a2 alpha square plus b2 alpha plus c2 equal to 0. Equation 1, equation 2. Now just solve these two like a linear equation in two variables. That's all. Now whatever the problem is asking, whatever the things which are unknown, just simplify these two and you will reach to some result definitely. Like there is no chance that you solve these two and you don't get to any conclusion. Never. It is never going to be possible. Always you just subtract them, add them, whatever you want to do, you do with them. You just need to manipulate these two equations. No formula is there. Like there are some formulas written in the books. These are derived from the same result. But what I'm telling you, formula, we are not going to use it. In fact, in whatever common questions we have from common roots, the formula is never going to be useful. This is the simplest which you can think, which you can do. Assume that alpha is the common root, replace them in the equations and just proceed. You are going to get the result for sure without any doubt. Okay, so this is what you have to do. This is what you have to do when you have only one root common. Very simple. Assume alpha is a common root, put them into the equations and just solve. You will reach to some conclusion. Okay, that's all. Nothing else. No formula. And when both roots are common, now is the easiest thing. a1x square, b1x, c1 equal to 0. And if we have a2x square plus b2x plus c2 equal to 0. If you are saying that both roots are alpha comma beta, alpha comma beta. That means coefficient must be in proportion. What do I mean? That they must be like, equation 1 should be something like a1 into x minus alpha into x minus beta equal to 0, and the second equation should be a2 into x minus alpha into x minus beta equal to 0. So this means all the coefficient will be definitely in proportion. So the condition will be, if both roots are common, the condition is going to be a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is the condition which you are going to have if both roots are common. Clear? I hope I have made my point here. So in common root questions, this is what you are going to deal with. Both roots common, all coefficients will be in proportion. One root common, assume alpha is a common root, put them in equation and solve. Fine. Let's move to questions, guys. Now this is very simple. What is being said? Have a common root. Now this time one equation is already in the simplified form, so there is nothing to think of, right? X square minus 7x plus 10, you can simplify. This is x minus 5 into x minus 2 equal to 0. So here either 5 is common root, you will have two conditions. Like either 5 is a common root or 2 is common root. Right? Because you already have information about roots of one equation, there is nothing left to solve, guys. Just find out the root and check with them. So 5 is common root, then suppose this is gx. Suppose this is gx. So g of 5 will be equal to 0. So you'll put it there. So 25 minus 25 plus c equal to 0, you get c equal to 0. And if 2 is common root, then g of 2 will be equal to 0. Put there. So 4 minus 5 into 10, 10, c 0, c will be equal to 6. Is my point clear? Is my point clear? I hope this is not difficult for you, right? Since we already were aware of the roots of one equation, so there was nothing left to solve. I hope the point is clear. Moving on, guys. So what is the question here? If equation ax square bx plus c and 2x square plus 3 have a common root, then a is to b to c equals. Now see, this question is given to fool you. Why I'm saying like that? See, they're saying that a, b, c are all real, and the second equation 2x square plus 3x plus 4 equal to 0. Guys, do you notice something about the discriminant here? What is discriminant? B square minus 4ac, negative. So if discriminant is negative, both roots are going to be imaginary. Can you have one common imaginary root? Is that possible with real coefficients? Never. Right? So if we have real coefficients and roots are imaginary, then both roots will become common. By if this quadratic has one root alpha plus iota beta, the other root will be definitely alpha minus iota beta. So the other quadratic also will have alpha plus iota beta, alpha minus iota beta is common root, because the roots will be in conjugate pair. If one is alpha plus iota beta, the other one will be alpha minus iota beta. Understood? So since we have the condition that both roots are common, so the coefficients will be in proportion. A by 2 will be equal to b by 3 will be equal to c by 4. So 2 is to 3 is to 4 will be the correct option. Clear? And you see a, b, c belonging to real is given, so there is no doubt about our answer. Fine, guys, let's solve next. So what is the question here? Let a comma b is real, a is non-zero. Equation ax square, equation is ax square minus 2bx plus 5 equal to 0 has a repeated root alpha. Now, repeated root, right? Repeated root, right? This has roots as alpha comma alpha. Now, repeated root, do you remember the condition? Discriminant definitely is 0. Discriminant is 0, right? Or you can simply just use sum of roots and product of roots. Like alpha plus alpha will be equal to minus 2b by a, right? And this product of roots, alpha square will be equal to 5 by a. So we have this information about this quadratic. Ax square minus 2bx plus 5 equal to 0. Alpha plus alpha is 2b by a and alpha is 5 by a. Clear? Fine. What else we have to know? The second quadratic. Which is also root of the equation has a, okay, so x square minus 2bx minus 10 equal to 0. Beta is the other root and one root is common, alpha is the common root. So has roots alpha beta. Okay. So this quadratic has common root, this quadratic has root alpha beta, and this one has root alpha into alpha, alpha and alpha. So what is it saying? What is alpha square plus beta square? We have to find out alpha square plus beta square. So let's analyze this given data. So guys, alpha plus beta and alpha information is given here. So a alpha square. Okay. So what is alpha plus beta here? Alpha plus beta is 2b. And what is alpha into beta? Alpha into beta is minus 10. Right? Alpha plus beta is 2b. Alpha into beta is minus 10. So I can definitely replace beta here. So alpha plus here this is alpha. And guys, we already have alpha in terms of a. If you see, if you divide these two equations, like alpha here was b by a from here, and alpha square is 5 by a, right? So from these two, can I say that the alpha value is going to be equal to how much? If I divide these two, it is equal to 5 upon b for sure, right? 5 by a divided by b by a, alpha square by alpha is equal to 5 upon b. So we have alpha in terms of b. So I can replace it here. Getting my point? Alpha I can replace in terms of b. So alpha is 5 by b, right? Alpha is 5 by b plus. What is beta? Beta is minus 10 by alpha. Minus 10 by alpha, and alpha is how much? 5 by b. Alpha is 5 by b equal to 2b. So we are going to get a simple quadratic here, right? So this is 5 minus this is how much? 5 is equal to 5 by b is equal to 2b plus 2b, right? So 4b square. 4b square is 5 guys. We got value of 4b square. So b value we got. Okay. B value we have got 4b square equal to 5 is one condition that we have got, and definitely we can get a also from there. Right now, what is alpha square plus beta square? Alpha square plus beta square will be equal to alpha plus beta square minus 2 alpha beta. So alpha plus beta is 4b square minus 2 alpha beta. What is that? Plus 20. So 4b square is 5. 5 plus 20. The answer is 25. 25 is the answer. Clear? Just to make question complicated, see, in fact, there is no such use of common roots here. It is saying that the alpha is the common root, but you see, just by using simple relation between roots and coefficient, we are able to solve this problem. Clear? It's only about calculating with peace. Fine. Let's solve next one. Now, what is the question here? Lambda is non-zero if alpha and beta are the roots of the equation x square minus x plus lambda equal to 0. Roots are alpha and beta. Fine. And alpha and gamma are the roots of the equation. Okay. Alpha and gamma are the equation 3x square minus 10x plus 27 lambda equal to 0. Roots are alpha and gamma. Almost same, right? 3x square minus 10x plus 27 lambda, x square minus x plus lambda, right? 2 lambda. X square minus x plus 2 lambda and alpha gamma 3x square minus 10x plus 27 lambda. Fine. Alpha is the common root. So I can get some relation between alpha and lambda, right? I can say here this is alpha square minus alpha plus 2 lambda equal to 0. I can put alpha in this equation also, and I can write 3 alpha square minus 10 alpha plus 27 lambda equal to 0. Now see, I can eliminate alpha and I can get some relation between alpha and lambda, right? So if I multiply first equation by 3 and I subtract it from the second one, okay? Multiply first equation by 3, subtract from the first equation. So 3 alpha square will cancel out, minus 10 alpha plus, so this will be minus 7 alpha. and 27 lambda minus 6 plus 21 lambda equal to 0. You see, we have got a very beautiful relation that alpha is 3 lambda, right? We got alpha in terms of lambda, that alpha was the common root. I had substituted in both equations. I got alpha equal to 3 lambda. Now the job is not done still. What we have to do? We have to find out beta into gamma by delta, right? Now for the second equation, okay, what is alpha into beta? Guys, alpha into beta is 2 lambda. And what is the gamma, alpha into gamma? Alpha into gamma is 9 lambda, right? Alpha into beta, alpha into gamma, that is all we have now. So, so what is beta into gamma? If I multiply everything, so alpha, beta, gamma, alpha will be equal to 18 lambda square. So we have alpha square into beta into gamma is equal to 18 lambda square. So alpha is how much? 9 lambda square, right? Alpha is 9 lambda square. So 9 lambda square is equal to beta into gamma equal to 18 lambda square. So we have beta into gamma is equal to how much? We have it as 2. So we have got beta into gamma also. Now we need value of lambda. Now we need value of, we need beta into gamma. We need value of 1 upon lambda. Guys, we can find out lambda very easily by substituting. You see, alpha is a root here, right? Alpha is a root here, and alpha is equal to 3 lambda. Alpha is 3 lambda. So 3 lambda will satisfy it. So 9 lambda square minus 3 lambda plus 2 lambda equal to 0. So what do we have here? This is lambda equal to either 0 or we have 1 upon 9. We have two options, 0 or 1 upon 9. Right? Since alpha is 3 lambda, so we can put back in this equation. When you put back, we get alpha equal to 3 lambda. 9 lambda square minus 3 lambda. So this is lambda comes out 0 or 1 upon 9. Now 0 cannot be possible because it's mentioned already. Then alpha is non-zero. So what is the lambda? Lambda is 1 upon 9. So 1 upon 9 multiplied by 2, it will be 18. That is all. You see here they mentioned that alpha is a common value. Same thing I did. I subtracted. I get relation between alpha and 3 lambda. I put that back in. I had put that back in the equation. I keep on. I just kept on calculating. I just kept on calculating the relevant things which I need there for my like that final value, and I got them. Right? Beta into gamma, I got it. Alpha was very simple to get it from here. And in fact, instead of doing that, once you put alpha equal to 3 lambda here, we get lambda value, and then you can clearly find out everything. Don't even need to write that. Instead of doing that, you can simply go for alpha equal to 3 lambda in this equation. You can find lambda, and once you get lambda, your job is over. Clear? So let's move to next question, guys. Now what is this? X square plus px plus q is 0. Have a common root, so that 1 plus p plus q is 0. And their other roots are the roots of the equation this. Excellent question. So we have two equation, and what is given? What is given? Have a common root. So let's say alpha is common root. Again, that is how I start. Assume, okay. Assume that alpha is common root. So if alpha is common root for both these equations, then what we'll have here? Alpha square plus p alpha plus q is 0. Alpha square plus p alpha is 0. And alpha square plus q alpha plus p is 0. So if I subtract these two equations, then p minus q into alpha plus q minus p equal to 0. So obviously p and q cannot be equal, so alpha becomes equal to 1. Right? P and q, if you make them equal, it will be a same equation. So that makes no sense. So p will not be equal to 1, p not be equal to q. So from there we got alpha equal to 1. You see, we got common root value itself. By subtracting the equations, we got the common root, it is 1. So once that we have got the common root, let's do something with it. Now alpha is 1, right? So if alpha is 1, then it will satisfy this equation. Right? Alpha is 1, alpha. We got the common root. We have got the common root value. So we'll put back in the equations, it will satisfy it. So we'll have 1 plus p plus q equal to 0. We'll get p plus q equal to minus 1 from here. Or I think we had to prove that same thing. right? We put alpha equal to 1 here, and then we got 1 plus p plus q is 0. Fine. Now what was the next thing? That we had to find out the equation with the other roots. Let's say the first equation, right? The first equation has root alpha beta, and the second one has root gamma delta. Sorry, alpha gamma. So we need to frame quadratic with roots beta and gamma. Beta and gamma. So what we can do now? We have info about alpha plus beta. Right, first equation. Alpha plus beta is how much? Minus p. Or we can use product also. Guys, we can use product also. What is alpha into beta for first equation? Right, we have assumed that first equation roots alpha into beta. So alpha into beta is q. Alpha is 1. Since alpha is 1, so beta will be q. Similarly, we have alpha into gamma. Alpha into gamma equal to p. Alpha is 1, so 1 into gamma is p. So we got gamma value also, gamma is p. So gamma and beta are known. Gamma and beta are known. So what will be equation? Equation will be x square minus beta plus gamma times x plus beta into gamma equal to 0. This is how frame the quadratic. This is how we always frame the quadratic with the known roots. What is beta plus gamma? Beta plus gamma. Beta plus gamma will be p plus q into x. Beta into gamma will be p into q equal to 0. But that is not what we had to prove. We had to prove x square plus x plus pq. But there is one more result which we can use. What is that? See, p plus q, where is it? Where is it? Where is it? P plus q plus 1 is 0. So can I replace p plus q as minus 1? Just replace it minus 1. So this becomes x square plus x plus pq equal to 0. This is the quadratic having roots gamma and beta. The other roots. The other roots. Clear? So I hope you have definitely understood this expression, all this illustration. And what exactly I'm doing? The same thing which I told you. If they say that they have one root common, I'll simply assume root, I'll put them into equations and I'll solve. And that is what I've been doing in every single question here. Clear? So I hope this thing is fully clear to you. Moving on to next funda of graph. The graph plays an important role not just for this chapter. There are many chapters where you are going to use a graph of quadratic to understand properties of some equation or something other. The graph of quadratic, every single student has to know how to draw the graph. Because when you will come to this parabola section, when you do y square equal to 4x, x square equal to 4ay, and there if you don't have idea about plotting graph, your life will be ruined. Right? Because in coordinate geometry, it's very important to plot graph. So many parameters are there. If you don't know how to plot, you are ruined. So let's see how to draw graph of quadratic expression in simple steps. It's very simple. See, I'll mention some key points here. So for any given equation y equal to ax square plus bx plus c, okay, this will be a parabolic graph. The shape is parabola, right? The shape is either upward parabola like this, or it will be downward parabola. Upward or downward, right? Upward parabola or downward parabola. Now the upward parabola, downward parabola are related to the leading coefficient a. So when is this upward parabola? When leading coefficient is positive, and when leading coefficient is negative, like if you are drawing y equal to minus something of x square, it will be downward. This is upward parabola, right? So they will be having only two shapes, either upward parabola or downward parabola. Fine. Now about that parabola, you see, you can see one turning point, right? You can observe one turning point. Now what is that turning point? You see in that shape, like when you plot it, let's say. Now what is that turning point? You see, this turning point is the thing where the differentiation of the curve is 0. Like the slope, you see, when you draw a tangent to it, it becomes parallel to x-axis. The slope is 0. Here, slope is nothing but 0. And that is called vertex of the curve. Vertex is the point where the dy by dx is going to be 0. what is that point? You see, for y equal to x square plus bx plus c, if you find out vertex, what is vertex? Vertex is the point where the slope is equal to 0. That turning point. The turning point is the point known as vertex where the slope is 0. So put dy is equal to 0 to find vertex. The turning point is known as vertex, and to find that derivative equal to 0. So you have 2ax plus b equal to 0. So x equal to minus b by 2a. And at this x, when you put it in the equation here, then you get y equal to minus d by 4a. So memorize it, that these are the coordinates of vertex. That the vertex coordinates are going to be, right, this is vertex, and vertex coordinates are going to be minus b by 2a minus d by 4a. Remember it. Like this will be minus d by 4a and this will be minus b by 2a. Right. So in this graph, this is the first thing which you have to remember, the vertex of the parabola. It is the turning point. And what is that turning point? The tangent, if you draw to it at that point, it will be parallel to x-axis. This is the first thing. The second thing apart from vertex which you have to know is about the symmetry. You see, you draw any parabola, it is symmetric about vertex. It should look symmetric about vertex, right? X part of vertex. A parabola will be always symmetric. If you are drawing it, draw it in a way that it looks symmetric about x equal to minus b by 2a. So this is what I'm going to write. Parabola. The curve is symmetric. The symmetric about vertex point, about vertex x equal to minus b by 2a. Okay. It is symmetric about the point x equal to minus b by 2a. Now symmetry, what does symmetry mean? Suppose this is y. Suppose this is fx. Suppose you call this as some fx. So by symmetry I mean that from that minus b by 2a, if you go x distance to the right or to the left, the value will be equal to f of, from that minus b by 2a, you go x distance to the right or you go to the left, the values are going to be equal. This is what the symmetry word means. You go to the right, to the left, the same length. The best example is x square. See, when you draw y equal to x square, okay, let's say this is y equal to x square. Now y equal to x square. Now this is vertex is 0, 0. You can see vertex is 0, 0. So if vertex is 0, 0, you see this is your fx x square. You can see f of vertex is 0. So 0 plus h is always equal to 0 minus h, and that is equal to h square. This is what I mean. That you go h length to the right. You go h length to the right or h length to the left. These two will be equal always h square. These two will be completely symmetric. And that is what the word symmetry means. I hope it is clear. Now don't get into too much of the word symmetry. To draw graph, we need to know vertex, that's all. We need to know the sign of leading coefficient so that we know if it is upward or downward. This is the first thing we need to know. The second thing is this vertex point. That is all we need. And the third thing is, just keep in mind, you draw it in a way that it looks symmetric about vertex. These three, that's all. Let's plot some, guys. Let's plot some curve. Suppose we have to plot y is equal to x square plus 4x plus 6. Suppose we have to plot this. Y equal to x square plus 4x plus 6. So what did I observe? What all things I need to observe? First thing, that leading coefficient A is positive. You can see this is 1. So leading coefficient A is positive. So this is going to be upward parabola. Right? First thing we observed, A is positive. Second thing, vertex. What is the vertex point? Minus b by 2a. So minus b by 2a. This is b by 2a. And minus d, b square 16, 4ac. Minus d by 2a, 4a, sorry. Okay. Vertex point minus b by 2a minus d by 4a, and a, b, c, d are having the that particular meaning that you already know of. So this is it. So it is equal to minus 2 comma 60 minus 24 minus 8, so it becomes 2. So we got the vertex, we got the vertex point, we got the leading coefficient. Now at x equal to 0, at x equal to 0, what is y? Y is 6. Let's plot vertex and this at the on the coordinate axis. So minus 2 comma 2 is the vertex, so it will be somewhere here. Okay, minus 2 comma 2. And see, since it is symmetric about vertex, so I need to draw always the line corresponding to x equal to minus b by 2a. So this is the point minus 2 comma 0, and this is the vertex point minus 2 comma 2. Right? I have drawn the vertex point. Now at x equal to 0 it is 6. So I need to draw that also. At x equal to 0 it is 6. 0 comma 6. That's all. These 2 points at x equal to 0, vertex and the sign of a. That is all you need. Now you know that it has to look symmetric about this line. This is vertex wala line. The graph has to look symmetric about vertex line. So you have to plot it in such a way that it looks symmetric. So see, this is how I'm going to plot it. This is how we plot it. That's all. You can clearly see that this is the turning point and it is the graph is looking symmetric about minus b by 2. Clear? And this graph is not cutting x-axis, right? So y can never be equal to 0. You can see, no? Like see, this is graph of y equal to this curve. So what information we can have from this graph? Guys, this is also equally important to extract the relevant information from the curves. So from this graph, what can you see? That the curve is not intersecting. Not intersecting. This graph is not intersecting x-axis. Right? So we can clearly tell that there are no roots. You see y, what is minimum y? That y is starting with 2. Y is starting with 2. Y is always greater than 2. Y is always greater than 2. Y can never be equal to 0. So that means we don't have any real x for which y is 0. So here we can see discriminant is less than 0. If I give you a random curve and if I ask you what is value of d, sign of d at least, you can easily predict from the curve. If it is not intersecting, right, that means y is not 0. You can clearly see that y is minimum 2 here. So if y is not 0, that means roots are not real. Clear? If the graph is not intersecting x-axis, roots are imaginary. This is one graph. Let's plot one more, guys. Let's plot one more. Where is this gone? Okay. Let's plot one more, guys. Let's plot two more. Let's plot quickly. So y is equal to x square plus 2x plus 1 and y is equal to minus x square. Okay. Y equal to minus x square and plus 3x minus 2. Let's plot these two. Okay. Let's plot these two. So x square plus 2x plus 1 and this. So x square plus 2x plus 1, what will be vertex? I know the points already. Okay. So the points are minus 1 comma 0. At 0, it will be 1. So this is how the graph will go. Passing through. At x equal to 0, it is 1, 0 comma 1, and this is the vertex. Now you can see the graph is touching. The graph is touching x-axis. And what about the roots, guys? What are the roots? It has repeated roots. Repeated roots. So if the graph is given and the curve is touching x-axis, it will have d0. That is what we have to conclude. That if ax square plus bx plus c, if ax square plus bx plus c touches x-axis, this means we will have discriminant equal to 0. This will be condition of repeated roots. And the other hand, this graph you can see the roots are 1 and 2 basically. Roots are known here. So if you plot it by all the data, this is how it comes out. Okay. And see, leading coefficient negative. So this is how we draw it. And what about its roots, guys? What is discriminant? b square minus 4ac. So now minus 8, 1, positive. So when discriminant is positive, you can see the graph will be having two real. What are those points, guys? What are these points? These points are roots, alpha comma 0, beta comma 0. These points on the axis are nothing but roots of that quadratic. So if a quadratic is having real roots, then it will intersect. So this also we can write, right? If y equal to ax square plus bx plus c intersects x-axis, this will mean it will have two real roots. Two real roots. I hope the funda is clear. It is going to have two real roots. Okay. So if a curve is given, you can always predict about sign. Suppose I am giving you y equal to graph of ax square bx plus c, where discriminant is b square minus 4ac. So if I only give you graph and tell you to identify ABCD, you can always do. Like what I'm going to do, I'm going to give you identify ABCD, A comma B comma C comma D. So I'm drawing graphs. Suppose this is one graph and the second one, something like this. In these two graphs, see, first graph. By the shape of parabola, up or downward, we can comment about leading coefficient. Like A, C, D is very easy to find out. This is x equal to 0. This is 0 comma C point. So we can see A is positive, C is positive. Obviously D is positive because we have two real roots. Right? The graph is intersecting x-axis, so definitely it is having two real roots. So D is also positive. Now the only B is there, which we have to find out if it is like positive or negative. So for that, vertex will be helpful. You see, this is the vertex. So this here will be the vertex point minus b by 2a comma 0. And guys, you can see minus b by 2a comma 0 is lying on the positive x. So I'll say that minus b by 2a is positive. A is already positive, so that means b has to be less than 0. ACD, commenting ACD will take less than a second, right? You will still see graph and you will comment instantly, but commenting about B will take 2 extra seconds because that we use vertex information. The X part of vertex will tell you what is sign of B. Like in the second graph, just see what will be the sign in second graph. Just tell me. You can see this is the vertex. So here A will be negative. Right? So you can see that if we extend the graph, it will cut somewhere here. So this is 0 comma C. 0 comma C. At x equal to 0, you see at x equal to 0, y is C. So y is negative. So C is negative here. So A is less than 0, C is less than 0. There are no real roots. This is never going to intersect x-axis. This curve will never cut x-axis. So discriminant is negative. What about B, guys? Now minus b by 2a is still in first quadrant here, right? This is minus b by 2a comma 0. Now a is negative, so when you cross multiply, sign will change. So minus b will become less than 0. So b will be positive, right? When you cross multiply 2a, a was negative in sign. So when we multiply by negative number, inequality sign reverses. So minus b will become less than 0. So b will become greater than 0. So now we have sign of ABCD. Is that point clear? Right? It's very simple to comment about sign of ABCD even if only graph is known. I hope these points are clear to you. So moving on, guys. Okay, guys. So let's move on the concept of concept of quadratic when discriminant becomes negative. Now, why I am teaching it as a special case, because the graph will show a special behavior when discriminant is negative, just like you have seen in the previous two graphs. See. When D is less than 0, right? So if A is negative, if A is positive, right? For some quadratic y equal to ax square plus bx plus c, okay? If D is negative, then there are two types of graph possible. You know that when D is negative, roots are imaginary, so the graph will not intersect x-axis. So if A is positive, it is going to be always upward, or if A is negative, if leading coefficient is negative, it is going to be downward curve. Okay. In both these cases, do you observe some special thing about y? You see, this is graph of y equal to x square plus bx plus c. In the first graph, you can observe about y. You see, this is the minimum value, right? This is the minimum value. You can always see that y is always greater than some positive value. Like this must be something positive. In this case, y, which is equal to ax square plus bx plus c. So in the first one, y is always positive. First one, y is always greater than 0. In the second one, right, in the second one you can see this is the minimum value of y, and after that it keeps on getting more negative. So y is always less than 0, right? So what is sign of y, right? That is dependent on the leading coefficient a, or you can say c also. Like in this case c is positive, in this case c is negative. So sign of y is exactly similar to sign of leading coefficient a or sign of constant c. I hope it is very clear from the graph, guys, very clear from the graph. So we can generalize one result. In the previous graph, I'll show you one thing. See, when d is positive, like this case, you can see discriminant is positive because we have two real roots. So here you can see for this section, guys, for this section, y is positive. Here y is positive. But if you go down there, here in this part, y is negative. Clear? So when discriminant is positive, in that case y can be positive as well as negative also. But when discriminant is negative, when the graph is not intersecting x-axis, you can see either it is always positive or always negative. Y at every single point, y is either positive or negative. So we can conclude one thing here, that if fx is equal to something like ax square plus bx plus c and the discriminant d is less than 0, then the sign of fx, right, then fx will be greater than 0 for all x if leading coefficient a is positive or constant c is positive. A and c will be of similar sign. If discriminant is negative, no, a and c will be of similar sign, right? So fx is positive for all x or fx is less than 0 for all x if a is less than 0 or c is less than 0. These two you have to understand it from the graph, and you have to remember as well. And I don't think it is difficult if you can understand from these two curves also. I don't think that there is any difficulty at all in understanding these things. Fx is always positive. You see, fx is always positive for any value of c. You choose any x here. You choose any x, y corresponding to it is always positive, right? You choose any x, for that y is negative. You choose any x, y is negative. Clear? So that is why d less than 0 is a special case. When d is negative, ax square plus bx plus c will always maintain same sign throughout. And whenever in the problems you see something is having same sign for all x, there you must understand that they are hinting about discriminant, that discriminant has to be negative. Clear? So I hope this thing is clear to you. Let's solve some problems related to it. And before that, not problems, like we'll see some problems later on, but with this maximum minimum concept as well. Now see, when we are drawing graphs for a greater than 0, right, either we have a graph like this, or we have graph sort of this, or we have graph something like this. In all these three cases, guys, in all these three cases, you can see we have a minimum point here, right? You can see y starts from minus dy 4a and it keeps on going till infinity. Same seen here, minus dy 4a till infinity. Same here also, minus dy 4a and then keeps on going till infinity. So can I say that ax square plus bx plus c, the range, the values of y, that y will be minus of d by 4a to infinity for all real values of x and a being positive. This is the first one. And the second case, see, this is for a positive. If a is negative, I'll just show only one curve. If a is negative, this is how we draw. Now this time, the maximum will be minus d by 4a, right? And after that, it keeps on decreasing. It will start with minus, it will be, maximum will be minus d by 4, it will keep on decreasing. So in the second case, y will be the max, it will be what? Minus infinity to minus d by 4a if a is less than 0 and we are talking about all real values of x, right? This is how you find out the maximum and minimum. Clear? Maximum if a is positive. See, if the graph is upward parabola, you will have only defined minima. If we are talking about entire values of x, if we have like a scope of going from negative infinity to positive infinity, so we'll have only one minimum. Otherwise, the graph will keep on moving to infinity. And if leading coefficient is negative, then we'll have a maxima. We'll have some maximum point, but there will be no fixed minimum. We can keep on going towards minus infinity. Clear? So remember these two points. One more thing I'll like to explain here. It's not like that they will always see the previous two results are valid only if x is all real. If we are considering minus infinity to plus infinity, what if they ask in restricted domain? What if x is only from x1 to x2? Okay, if they ask range in restricted domain, if they want range in restricted domain, that x belongs to only x1 to x2. So what to do in this case? If they want range in restricted domain, then what you have to see, you just need to follow these steps. What are the steps, guys? See, the first thing, find critical points. I mean, by critical points, I mean put f dash x equal to 0. Okay, put f dash x equal to 0, and that is your critical point, basically the vertex. So I think I instead of writing these, I'll simplify a bit. You have to find vertex. Find minus b by 2a, right? If minus b by 2a is an element of x1 to x2, right? If minus b by 2a is an element of x1 to x2 set, then you need to find, like this is the only step here, find f of x1, f of x2 and minus d by 4a, right? That is basically value at minus b by 2a. So you will find these three and then write minima to maxima of these three. From these three you choose minimum, these three choose maximum. This will be your range. Okay, if that minus b by 2a is satisfying this thing, this is how you write range, minima to maxima. And if minus b by 2a does not lie in that range of x1 to x2, then simply find f of x1, find f of x2, and the range will be from minimum to maximum, where minimum maximum will be decided from these two. Very simple. You just need to find out that vertex. If that vertex is lying in the given set, you need to calculate all three, minus d by 4a also, right? And see, I'll give you some idea that why this is happening. See, like in this case, see, when vertex will lie, then obviously we'll have a point of minima or maxima, right? If vertex is lying in some given domain from x1 to x2, you can clearly see that we will get maxima at vertex or will get minimum at vertex, right? So that is why we always calculate vertex point. Okay, the actual logic will be taught you in application of derivative. So by chance, if you get range in restricted domain, This is what you have to follow. Let me give an example. Suppose question is find range of y is equal to x square minus 2x plus 4, where x belongs to 0 to 5. Right, first case, and second case x belongs to 2 to 3. So we'll find out range in both these cases. Now in first case, let's see what is the minus b by 2a. Minus b by 2a is minus 2 divided by 2, it is 1. So in first case, 1, that minus b by 2a is an element of 0 to 5. You can see minus b by 2a is lying in that range. So what we do? We find out f of x1, we find out f of x2, and we find out minus d by 4a. What is f of 0? Put 0 here in this, so it will be 4. What is f of 5? So 5 square 25 minus 10, 15 plus 4, 19. And what is minus d by 4a? That is the x minus 1 whole square plus 3. It is 3. So you can see 4, 19, 13. So we can write range y will belong to minimum 3, maximum 19. This is the range. Minimum is 3, minimum of y is 3, and maximum is 19. This is what I meant by writing this logic here. Okay. And in the first one, like when in the second one, when it is 2 to 3, so you can clearly see in the second one, the vertex point does not lie between 2 to 3. The vertex is not lying between 2 to 3. So only we have to find f of 2, f of 3. So range f of 2 is how much? 2 square 4, 0, 4. And f of 3, 3 square 9, 9 minus 6, 3 plus 4, 7. So y will belong to minimum 4, maximum 7. This is how you calculate. And if x is given all real, if they don't mention any x, you know how to do. Right? This is the result we'll use. This is the result. Minus d by 4a to infinity. Okay. Minus d by 4a to infinity if a is positive. And if a is negative, for all real x, minus infinity to minus d by 4. And I hope the logic behind all these are also very much clear to you guys. Okay. So let's move on to some problems now. Now, what is the logic behind these three? We need to understand what is the logic behind finding range of quadratic upon quadratic, linear by quadratic, right? These four forms, and these are being asked in different exams, so you have to know it, right? What forms we are going to do? This is like linear by quadratic, or quadratic by linear, or quadratic by quadratic. The logic is going to be useful for these three forms. Whatever I am going to teach you will help you find the range for these three forms. So what is it? See. For all these forms, I'll give you an example. Okay, I'll give an example, or let me write a like standard thing. Like here, what we do? Like suppose y is equal to something, ax square plus bx plus c divided by px square plus qx plus r. So we cross multiply it to y. So this becomes something like this. Y into some quadratic. Now after cross multiplying, right, the first step will be you cross multiply denominator to the numerator, then form a quadratic in x. Like this will be something f of y into x square, some g of y into x plus some h of y. Right, f of y, g of y, h of y, that means we have some coefficient in a function of y. Right, after cross multiplication we formed a quadratic in x. Then you just put d greater than equal to 0. Why I'm saying so? Because they will always mention that x is all real. They will always mention that x is all real. So check for d greater than equal to 0. Also check for if fy equal to 0 is giving real value or not. Now what do I mean by this? See, fy is coefficient of x square. So if you make fy equal to 0, now you will have just a linear expression, and discriminant does not exist for linear combination. Like if I don't see, if I don't see this section, if I see only gyx plus hy, that is a linear expression, and discriminant has nothing to do with linear. So apart from d greater than equal to 0, you must solve one more condition. You have to check by putting that fy equal to 0. So you see, if you put fy equal to 0, is it giving you real x or not? If it is not giving you real x, if it is giving you some absurd relation, discard that thing. It will not be in range. Okay. So let me show you through an example. Suppose guys, we need to find out range of, suppose question is find range for y is equal to x square plus x plus 2 divided by x square plus x plus 1 for all real values of x. Suppose this is what we have to find out. Okay. Range of quadratic upon quadratic, x is all real. So same thing, we'll cross multiply. This will be yx square plus yx plus y is equal to x square plus x plus 2. Now you can see this is a quadratic. X square 1 minus y plus y minus 1 into x plus y minus 2 equal to 0. I have framed a quadratic in x. Right? This will be always our second step. First step, cross multiply. Second step, form a quadratic in x. Now x is real. Guys, x is real. So discriminant will be greater than equal to 0. What is discriminant? b square y square minus 2y plus 1 is greater than 4ac. So 4 times y minus 2 into y minus 1. There is a negative sign. So let it be minus 4. Okay. So y square minus 2y plus 1 is greater than, this is minus 4y square. Then minus y minus 2y minus 3y plus 12y, and minus minus plus 3, so it will be minus 12. So we have 5y square, 12 and 2, 14y, right? 14y and what is next? 14y and 13 greater than 0. I hope it is correct. 4y square, 12 to 14y, 13, right? So I think there is some calculation error. Yx square plus yx plus y, x square plus x plus 2. So x square, right guys, this was y minus 1, no? This is y minus 1. This is y minus 1. I thought there is some error. This is y minus 1. Let me correct it. So b square greater than 4ac. So there is no sense of negative sign here. It is only plus 4. Okay. Fine. So this is y square minus 2y plus 1 greater than 4y square. This is minus 3y, so minus 12y, and this will be minus 3, so plus 12. So take that this to the other side. So 3y square minus 10y, right? And this is 2 here, so 4 to 8, right? This is 8. Again and again I'm writing wrong. This is minus 2 minus 1 plus 2, so 4 to 8. So this is 8 minus 1, 7. Less than 0. 3y square minus 10y plus 7. Now we can factorize it. So what is it? This is 3y square minus 3y minus 7y plus 7 less than equal to 0. Right, this will be 3y. If we take 3y common, this will be 3y minus 7 into y minus 1 less than equal to 0. So y will belong to 1 to 7 by 3. Right? But this is not it. You see, we have to check for the leading coefficient also. What if that leading coefficient becomes 0? I told you to always check for that. You can see, always check if that leading coefficient, what is that fy? That fy is leading coefficient of x square. So after solving for d greater than equal to 0, you need to check for that also. So if you check here, what if f of y is 0? Okay, you can see if you put f of y, let's solve it here guys. Let me solve it here. So now if f of y is 0, that means if y minus 1 is 0, you can see y becomes 1, So if you put y equal to 1 in the main equation, this becomes x square into 0 plus 0 into x minus 1 equal to you are getting some absurd relation that minus 1 should be equal to 0, which is not at all possible. So that means this y equal to 1 should be rejected. So y cannot be equal to 1, because if y is equal to 1, we are getting some random, like weird, not possible thing. So y will be excluded, y equal to 1 will be excluded. So the final range of y will be y belonging to 1 to 7 by 3, but this one will remain open, right? So this is how we solve for quadratic upon quadratic. And there is one more way, guys. There is one more solution. There is one more way to solve this problem. See, if you have a quadratic by quadratic expression of this type, if y is something like this, ax square plus bx plus c divided by something kax square plus kbx plus d. If you have y of this type, something quadratic by quadratic and of this type, then in that case, what you can do, see, what you can do, we can write numerator in terms of denominator. We can write this 2 as 1 plus 1, and then we can split it. Plus 1 divided by x square plus x plus 1. So when you split it, this y becomes 1 plus 1 upon x square plus x plus 1. So now value of y is dependent on x square plus x plus 1, and we do know how to find minima and maxima of it. So what is range of x square plus x plus 1? This is from minus dy 4a to infinity. Any quadratic where there is no restriction on x, leading coefficient is positive. So what is the range? What is the range? What is the range? Range is, you see, minus dy 4a to infinity. So using this, we can write range. It is 3 by 4, right? 3 by 4 to infinity. So if you want to minimize y, right? If you want to minimize this, then you will divide by maximum of this, and maximum is approaching infinity. So this will be 1 plus 1 by infinity. So it will be approaching 1 plus 0. It will approach 1. It will not be exact because infinity is involved, right? Now what will be y maximum? Y maximum you will divide by minimum. Minimum is 3 by 4. So it becomes 4 by 3, 7 by 3. So you see, from this method also you got it from 1 to 7 by 3. And that is what will be the best method if you have quadratic by quadratic of this type. I hope I have explained all these things pretty well. Every single calculation is going to it's being clear to you. Okay, so let's solve next point, guys. Let's solve problems now. So I'll simply tell you the logic. The integer k for which the inequality is greater than 0 valid for every x. That's it. This is what we want to see. They want this quadratic to be positive for every x. So what I'll do, I'll simply put d less than 0. What is discriminant? Minus 2 b square, right? B square will be less than 4ac. So b is minus 2 times 3k minus 1. B square is less than 4ac. So 4 into a into what is c? C is 8k square minus 7. That's it. You are simply solving a quadratic now, right? A linear equation type of thing. Integer k for which the inequality is greater than 0. Clear? Minus 2 times 3k minus 1, b square is less than 4a, and c is 8k square minus 7. So if you simplify, you see, you will get a range here. What is it? 4 will cancel out. I think this color will not be right. So this will be 3k minus 1 whole square is less than 4 will cancel out, and 8k square minus 7. That's it. We want that integer k which satisfies this. So you can check from options. Put k equal to 3. So 3 3 9 is 64, and this is less than, right? Put 3 here. 3 square 9, 9 8 72. 72 minus 7. This will be how much? 72 minus 7. It will be 65. So 64 is less than 65. I think this is correct. Put 2 here. 3 to 6. 6 minus 1, 5, 25. 2 square 4, 25. Those 2 is not, this is not satisfying. I think A is correct one, right? Because if you put 0, it will be 1 less than minus 7. That is also not correct. So 3 is the correct option. So this is the determining condition. Either you simplify it fully or just check from options. Okay. Moving on to next question. Now what does it say? M is chosen in the quadratic equation such that the sum of its roots. What is sum of roots? Guys, what is sum of roots? It is minus b by a. So it is 3 divided by m square plus 1. Right? Sum of the roots is greatest. Then the absolute difference of the cubes of its roots. Now this is greatest if you divide by the minimum. Right? If this is greatest, what will be alpha plus beta greatest? What will be greatest? When you divide by the minimum. And for m square plus 1, what will be minimum? 1. Right? Greatest will be 3 divided by m square, minimum can be 0. So it is 3. Right? So alpha plus beta greatest will be 3 and for m equal to 0. What do we want now? Then the absolute difference of the cubes of its roots. Then they are asking what is alpha cube minus beta cube. So I think now you have everything in terms of what? Alpha, beta, and because we have m value, this is alpha minus beta into alpha square, beta square minus alpha into beta. So this is alpha minus beta into this alpha plus beta whole square minus this is 3 alpha beta. You can simply put values and you can calculate. I hope it is clear. Clear? You want it to be maximized, so we divided by minimum. Clear? Fine. Let's see next one. Value of lambda such that the sum of the squares of the roots has the least value. Okay. Sum of the squares is sum of the squares of the roots. So our function which we have to maximize is sum of squares of root, which is alpha square plus beta square. What is it? What is it? It is alpha plus beta whole square minus 2 alpha beta. So sum of roots will be 3 minus lambda. So lambda minus 3 square minus 2 alpha beta. What is it? This is 2 minus lambda. So twice of 2 minus lambda. I hope you are able to understand here. 3 minus lambda. Right. So this is what? This is sum of squares. And we need to what? We need to. So the square roots of the has the least value. We need to minimize it. Guys, we have to minimize it. So what is the f lambda exactly here? This is lambda square minus 6 lambda, right? Minus 6 lambda plus 9 minus 4 plus 2 lambda. So this comes out as lambda square minus 4 lambda plus 5. So this will be lambda minus 2 whole square plus 1. This is sum of squares. Now we want to minimize it. Guys, see. Perfect square plus 1. So how can you minimize it if this is 0? Minimum when this becomes 0, because a square term is either going to be always greater than 0 or only 0. You cannot make square term negative. So if you want to minimize it, right, if you want to minimize it, so this thing has to be equal to 0. This perfect square has to be 0. So 0 plus 1, 1. So for what lambda? For lambda equal to 2. And that is what they are asking. That what is that lambda? Lambda will be 2. I hope the concept is clear. It's very, very simple, straightforward. Perfect square plus something, minimum will be that something, right? Because you cannot subtract square. You subtract this. You cannot make a square negative. Okay. Moving on. Lambda be the ratio of roots of quadratic equation in X. Okay. So we have been given alpha by beta is X. Alpha by beta is given is lambda. Now what they want? Then the least value of m for which lambda plus 1 by lambda is 1. Okay. Least value of m for which lambda square minus lambda plus 1 is 0. Least value of m. Lambda square minus lambda plus 1 is 0. What is lambda plus 1 by lambda? You can always find out here by, lambda is alpha by beta, right? So I think let's write it in terms of alpha beta. So lambda is alpha by beta. So alpha by beta plus beta by alpha is equal to 1. So this is alpha square plus beta square is equal to alpha beta. So alpha plus beta whole square will be equal to 3 alpha beta. I think we don't have any like range here. What is alpha plus beta? Minus b by e. So it is m times m minus 4 divided by 3m square whole square. 3 times alpha into beta. So 2 upon 3m square. Right? Least value of m for which this is equal to 1. So b by alpha and beta is c by a, 2 by 3m square. So you can simplify it. This is m square, m minus 4 square is equal to, this will be how much? 3 will cancel out. Again this will be 9. So 9 into 2, 18. 18m square. Correct? So you can cancel out m square from here. So you have m minus 4 whole square equal to 18. So m minus 4 will be plus minus 3 root 2. So m is equal to 4 plus minus 3 root 2. So this question is just of like 4 minus 3 root 2. C is the right answer. But see, this is not related to range, right? I think by mistake we have taken it here. It is not related to range at all. This is simple like relation between roots and coefficient. There was nothing special here. Skip this, okay? Let's solve one. What does it say? The number of integral values of m for which the equation is always positive, right? Now this is what we are interested in. The quadratic is always positive. So the quadratic is always positive for every x. Then d has to be less than 0 and leading coefficient will be positive. Right? That's all. If a quadratic is always positive, then discriminant is negative and also leading coefficient is positive. What is discriminant, guys? Discriminant is b square. So minus 2 into 1 plus 3m. B square is less than 4ac. So d is b square less than 4ac. So 4 into 1 plus 2m and into 1 plus m. So you will solve this equation and m should be greater than minus half. So you need to solve these two to get the answer. Is my point clear? Right? Minus 2. D, what is d? B square. B is minus 2 times 1 plus 3. B square is less than 4ac. 1 plus 2m, 1 plus m. And also intersection with m greater than minus half. Because if you want a quadratic, this quadratic we want always positive. This quadratic here, we want this quadratic to be always positive. So if a quadratic is always positive, then leading coefficient has to be positive, discriminant has to be negative. So this is discriminant made negative and this is leading coefficient made positive. We need to take intersection of these two. Just simplify and take. So how much is this? This will be 9m square plus 6m plus 1 less than. This will be 2m square plus 2m plus 1 3m and plus 1. So guys, I think this is very simple now. We can cancel it. This is 7m square. Right? This is 7m square plus 3m is less than 0. So m will belong to minus 3 by 7 to 0. But we have to take intersection with that also. Right? M should be greater than minus half. So this is minus 3 by 7. Right? I think it's already in the range. Is the calculation correct? I think it is correct. B square, right? 2. B square 1 plus 3m. So 9m square plus 6m plus 1. 4ac. Right? We have missed 1 4, guys. We have missed 1 4. Okay. This was b square less than 4ac. We have missed 1 4. We need to mention it there. So 1 4 will cancel out and this will be 9m square plus 6m plus 1 less than 4 times. So this is 2m square. So 4 plus 8m square and plus 12m. 2m plus m, 3m. It will be 12m. So if you calculate it, it is m square minus 6m and minus 3 less than 0. So this and intersection with this. So the calculation is up to you. Calculate and find out the correct answer. Okay, let's move on. Fx is given. It says minimum of fx is greater than maximum of gx. Where is minimum of x? See, this is a quadratic with leading coefficient positive. So what is will be minus d by 4? Like it will be minus d1 by 4a1 is greater than minus d2 4a2. Because the second quadratic is having leading coefficient negative, so it will be downward. So that vertex point will be for its maxima. So let's substitute the values. What is d1? The b square, right? d1 is the minus of b square minus 4ac, it is 8c square divided by 4a is greater than minus of d2. Guys, what is d2? b square minus 4ac will be 4b square divided by minus this is 4a2, so this will become minus 4. Clear? So this 4 will cancel out. So minus 4b square plus 8c square is greater than minus minus plus 4c square minus 4b square. So what are we getting here? This is 4c square is greater than minus, I think again we did some calculation error, guys. We have done some calculation error. d1 is b square, right? b square minus 4ac. This is d1. b square minus 4ac divided by 4a is greater than minus d2, which is b square 4c square minus 4ac. Okay, this will be 4b square. So 4c square plus 4b square. So 4c square will be greater than 8b square. So c square will be greater than 2b square. That is it. D is the correct option. Fine. Just like we have the standard result, substitute it and we got it. Moving on. So x square plus a minus bx plus is given, a b all real. Find the condition on a for which. First one is both roots of the equation are real and unequal for all real values of b. Now just read the question properly, guys. What it says, both roots of the equation are real and unequal. Okay, so if roots are real and unequal, so d will be what? Greater than 0. So what is d here? A minus b square is greater than 4ac. It will be 4 times 1 minus a minus b. It is a square b square minus 2ab is greater than 4 minus 4a minus 4b. What next is given is condition on b, that this is true for all real values of b. So if this is true for all real values of b, this frame a quadratic in b. So this is b square. Okay, this is b square minus 2ab, right? So this is minus 2ab plus 4b. So can I write 4 minus 2a times b and then plus a square plus 4a plus 4, right? A square plus 4a minus 4 greater than 0. This is what we are getting, and this is true for b all real. Getting my point? You have got a quadratic in b, and what you are saying that a quadratic is always positive. So when is a quadratic always positive? If leading coefficient is positive, which is already there, and discriminant is negative. So what is this discriminant? Discriminant is b square, right? This is what we'll do. We'll make this discriminant less than 0. Discriminant, this is d, so let it be d1. Discriminant of this quadratic. Now we have a quadratic in b. You can see b square, something into b, and some constant. So b square will be less than 4ac. So this is 4a square plus 16a minus 16. So 16 plus 4a square minus 32a is less than 4a square plus 16a minus 16. So 4a square will cancel out, right? And we have 48a, right? 48a, and that will be greater than 32. So a will be greater than 2 by 3, right? Similarly, you can solve for the second one also. I hope the first one concept is clear. First one, what did it say? That roots of the equation are real and equal. So D, which is discriminant of this quadratic, will be made positive. After that, we get an inequality in B. Now this inequality in B, see, this looks like quadratic. Something B square plus XB plus C is always positive for all real B. When it is true? When that quadratic discriminant is negative. So the second time this discriminant has been made negative, we got it. Similarly, you can try for the other one also. Moving on, guys. Find the range of values for C. This is always negative, right? They want this to be always negative. Just look at denominator. Denominator discriminant is B square 64. D is what? B square 64 minus D is negative, right? Denominator has negative discriminant. Denominator has negative discriminant and leading coefficient is positive. What does this mean? That the quadratic will have always positive value, right? So x square minus 8x plus 17 will be always giving positive values. But we want this to be always negative. So this is responsibility of numerator to make it negative. So this has to be always negative. So can we write, guys, that kx square plus twice of k plus 1 into x plus 9k plus 4 will be always less than 0. Because denominator is always positive. So numerator has to be always negative for all k. And that's all we need. If some quadratic is always negative, it means D is negative. What do we solve for? That its discriminant will be less than 0 and leading coefficient will be also less than 0. That's all we solve for. So what is its discriminant? B square. So I am leaving this up to you. You can simplify it. Calculation I am leaving up to you. Okay. Discriminant of this quadratic will be less than 0 and the leading coefficient k will be also less than 0. Right. So we have been using this funda from so many questions. So I hope this is clear to you. Okay. Solve this and then take intersection. And will be in intersection. So this is also homework for you. We have done quadratic upon quadratic. You see, you go for the second one funda, the shortcut type funda, right? So this is homework for you. Do give it a try. Now the second last topic of today, location of roots. See guys, in JEE main they have started asking questions from this section. And location of root, basically what we do, we have a quadratic given with some variables in it, and they will specify some condition about root, that your roots alpha beta are greater than some constant, or the roots are less than some constants, or some constant is lying between those roots. So they will mention some conditions. So using those conditions, we have to find out those variables. So there are 6-7 standard cases. I'll explain them. You just need to remember the result, and if you can understand them, it is the best thing possible. Because see, there are 7 cases, so it will be difficult to memorize all. So just try to understand the basic of each. See, the first case here is when both roots are greater than k. And what I'm going to consider? I'm going to consider this quadratic fx ax square plus bx plus c equal to 0. So my every single case is related to this quadratic. Okay. So when both roots are greater than k, so what will happen? See, what type of graph will be drawn? When both roots, so alpha beta, right? Suppose this is k, something like this, or k can be anywhere here. If this is alpha beta, then k will be here, right? Now you can see both roots alpha and beta are greater than k. Even if they have equality condition, it is fine. Then also you can see if d is equal to 0, still we have both roots greater than k, right? Now I'll ask, sir, what if it is vertically downward? That is also possible. That is also possible. You can make cases of such quadratic also, like this or this. Both are fine. And here we have k. Now guys, you can clearly see what are the conditions. See, what are the conditions? The conditions for this will be the conditions for both roots being greater than k. First case, see, discriminant can be either positive or 0, right? Even if d is 0, we can have both roots greater than k. So first condition, d will be greater than equal to 0. Second condition, you see, this is vertex point. So that vertex point minus b by 2a is always greater in the right of k. K is on x-axis. We are comparing values of x-axis. So the second condition will be the vertex point x is greater than that given value k. Right? The vertex point in both cases, this is minus b by 2a. So it is greater than k. Correct? Minus b by 2a is greater than k. After that, there is one more condition. There is one more. See, in the first graph, at x equal to k, if you find y, right, here we have leading coefficient positive, here we have leading coefficient negative. Guys, in the first graph, if you see what is this point? This point is x equal to k and f of k, right? We see f of k is positive. In this graph, at x equal to k, f of k is negative. First graph, f of k is positive. Second graph, at that given k, it is negative. So can we write in both? Like, see here, what is a into f of k? It is positive. A is negative. In the second graph, leading coefficient negative. Fk is also negative. So can I write that? Can I write this? That this is a into f of k is greater than 0. Right? K, this is fk, a is positive. So a into fk is positive. Here we have k comma fk. Now this is x-axis, y-axis. So obviously this is below. So it is going to be negative. So fk into a will become positive. So guys, whenever you have this condition that when both roots are greater than k, you need to solve these three and take intersection. These three cases, and then you have to take intersection. Right? This was the first case. When both roots are less than k. So now in this case, see, I'll draw a graph like this. So there will be only one change, guys. Right? This k will shift to the right. Now you can see both roots alpha and beta. Both roots alpha and beta are less than k. Right? We can have equality conditions also. Right? So will there be any change? Only one. The vertex is now in the left of k. Rest all are same. So first condition, d greater than equal to 0. Second condition, the vertex point, the vertex is now left of k. So minus b by 2a is less than k. Third is as it is, a into fk is still positive. So just intersection of all these three. This is when both roots are less than k. Okay. Third case, when k is lying between roots. Now this is the most asked case. The most important case, guys. See, when both roots, when k is lying between both the roots, then graph will be something like this. Right? This is, k can be anywhere. Right? K can be anywhere in between. It just simply has to be between alpha and beta. Alpha and beta. Right? This is the most important case over every, like, you are not just going to use it in quadratic related problems. Many times in calculus, this is going to be very, very helpful. Okay, and see, the condition is only one. Only one condition. You see, k can be anywhere. Right? You can place k anywhere in between. Now at x equal to k, what do you see? Suppose this is k. So this is x-axis, right? So at x equal to say k, this is fk, and here at x equal to k, suppose this is fk. Fk. So do you see one thing? Do you see one thing? In the first graph, fk is negative. In the second graph, fk is positive. But if you combine it with leading coefficient, Here A is positive, Fk is negative. Here A is negative and your Fk is positive. So can I write the condition? Only one condition is A into f of k less than 0. That is all. That's all. The discriminant is not needed here, that D positive, D. See, if you make D negative, then what will happen? There no need to mention that D is positive, because it is understood. It is already proven here. See why? Because if D is negative, the graph is something like this or something like this. In that case, A and Fk are of same sign. So when D is negative, then A into Fk is always positive. Right? A into Fk is always positive. So we don't need to mention condition of D for this case. And this is what you have to remember. And the most important useful case. Moving on, guys. The fourth case, when exactly one root lies between k1 and k2. So the graph will be something like this. Right? So I'm going only explain through this thing. Okay? So only one, okay. Right? So only one root is lying between k1 and k2. So this is k1, this is k2, and this is a root. So can you see, at k1 it is positive, at k2 is negative. So whenever this condition is there, whenever exactly one root is lying between k1 and k2, so again we have only one condition, that f of k1 into f of k2 less than 0. That's all. And this is also the one of the second most important case, second most. Okay, when exactly one root is lying between k1 and k2, you can see f of k1 into f of k2, the product will be negative. Similarly, if you make it vertically downward, same relation you will get. F of k1 into f of k2 less than 0. Only one condition, that's all. Let's see the next one. Case 5. Now when k1 and k2 lies between roots, k1 and k2 lies between roots. You see, k1, k2. Leading coefficient is positive here. So can I say, guys, can I say here that here this is k1, right? This is f of k2. Like this is k1 comma f of k1. So f of k1 and f of k2 both are what? This is just like the condition case number 3. If any constant is between roots, then leading coefficient into f of that constant is negative. Same thing. Write it for k1 k2 both. A into f of k1 less than 0 and a into f of k2 also less than 0. Don't write that f of k1 into f of k2 is positive. Don't write that f of k1 into f of k2 positive. Why? Because just assume if you have a graph something like this and you have k1, you have k2, still it is true. But is it satisfying that criteria? No. If you have graph like this k1, k2, f of k1 into f of k2 becomes positive. So it does not meet your criteria. Okay. So there might be confusion if you write f of k1 into f of k2 positive. What you have to write? A into f of k1 positive, negative, a into f of k2 negative, take their intersection, you will get the result. Let's see the next case. When both roots lie between k1 and k2. When both the roots. So now this time, this is k1 and k2 and both the roots. So this time d can be 0 also. Right. So alpha and beta are lying between k1 and k2. So what all condition will be there? First condition, d can be greater than or equal to 0. Second condition, you can see vertex point. The vertex point is between k1 and k2. So minus b by 2a will be between k1 and k2. Third point, guys, what will be third point? The third point will be a into f of k1 positive, and fourth point, a into f of k2 will be also positive. So you need to solve all these four and take intersection. That will give you the condition for both roots between k1 and k2. Okay. So there is one more. The last case, when one root is between k1 and k2, other between k2 and k3. This is also simple. This is like extension of the fourth case, k1, k2, k3. So can we say that we have exactly one root lying between k1, k2 and exactly one root between k2, k3, right? Just like the case number 4, exactly one root lying between k1 and k2. So for alpha we can write f of k1 into f of k2 less than 0, and for this one f of k2 into f of k3 less than 0. So if you have remember, like this is the first condition, second condition, you need to take intersection. So these are the 7 cases which you need to know to solve location of roots related problems, and you are definitely going to get all these questions if you have idea about these cases. Okay, so let's solve few problems, guys. Okay guys, so let's solve this question now. So the question says that let x square minus 3x be a quadratic equation, then find the values m for which both the roots are greater than 2. Now this is just the condition we did. Both the roots are greater than 2, right? So we know what to do. How many conditions we have? We have 3. The first thing, d should be greater than or equal to 0. So what is this equivalent? B square. So b square is greater than or equal to 4ac, which is 4 into m. So this is m square minus 6m plus 9 is greater than 4m. So m square minus 10m plus 9 greater than or equal to 0. We can factorize. So from here we get m belongs to minus infinity to 1 union 9 to infinity. So this is the first case. Okay. Now this was d greater than 0. The second one, the second thing being that minus b by 2a should be greater than k, right? Is greater than 2. So what is minus b by 2a? It will be m minus 3 by 2 will be greater than minus b by 2a. So 2 is greater than 2. So m will be greater than 7. So m belongs to 7 to infinity. And third, what is the third condition? A into fk is positive. A into f of k. What is k here? 2. Positive. A is 1, right? Leading coefficient A is 1 here. So what is f of 2? So 4 minus, put 2 here. So 2m, 4. This is 2m minus 3. So this will be plus 6 and plus m greater than 0. Guys, what we get? This is 4 minus 4 plus 6, 10. 10 minus m greater than 0. So m less than 10. So if you take intersection of all three, what do you get? 9 to infinity, 7 to infinity, less than 10. So if you take intersection of all, you will get m from 9 to 10. This is what you will get, guys. M will be from 9 to 10, right? So this is why the conditions are important to memorize. D positive, minus b by 2a greater than k, then af to positive. So solve for all three, then take their intersection. Like this final is, this all three, take intersection, and the intersection has given you this result. Okay, so I hope this concept is clear. Just remember the result, guys. That is important. Both roots are positive. Now whenever you see this thing, both roots are positive, this means that both roots are greater than 0. That's all you need to do. We will be solving for both roots greater than 0. That's all. That k is basically 0 here. Okay, so conditions will remain same. First one, that d greater than 0. So that d greater than 0 gave us this relation, that m is minus infinity to 1 union 7 or 9 to infinity, right? The second was minus b by 2a greater than k. So what is minus b by 2a? It was m minus 3 greater than 0. So m will be greater than 3. And the third condition, a into f of k is 0 here, is positive. Now what is the f of 0? If you put 0 here, this is 0, m should be positive. So if you take intersection of all three, guys, what is it? M will be 3 to infinity. This is your answer. Right? 3 to infinity, 9 to infinity. The intersection will be 9 to infinity. So I hope the points are clear. See, This particular section is easiest because if you remember the condition, you are simply simplifying inequalities. That's all. You are simply solving inequalities. Okay, let's keep moving, guys. One root is positive, one other is negative. Do remember this. Do remember this. The way they have asked this, one is positive, the other is negative. It means that 0 lies between roots. This is very important, right? If one root is positive, other root is negative, definitely 0 is between the roots. And we know the case 3, if k lies between roots, fk is negative. So the same thing, that f0 will be less than 0. Right? A into f0. So what is a there? A is 1 and f0 is m. So m will be less than 0. That is your answer. Understood? Moving on, guys. Okay, so this was asked in 2020. So what is the question here? A set of all real values of lambda for which the quadratic equation always have exactly one root in the interval 0 to 1. So I'm not going to calculate, you see, exactly one root. So we have that case, exactly one root between 0 to 1. So what is the condition? F of 0 into f of 1 less than 0. Right? We have written this as a special case. F of a into f of k1 into f of k2 less than 0. Exactly same thing. So f0 will be how much? It will be 2. And what will be f of 1? It will be lambda square plus 1 minus 4 lambda. Right? Plus 2. So lambda square minus 4 lambda plus 3 less than 0. So lambda will be from 1 to 3. Very, very simple problem, guys. Moving on to next one. If both the roots of the equation are real distinct and they lie in the interval 1 to 5, right? 1 to 5. So which case is this? Both the roots are lying between 1 to 5. So this is the sixth case, right? So I'm going to mention the condition. If roots are lying between 1 to 5, what all will solve? The first thing, D, right? And they are saying real and distinct. So D will be only positive. Second thing, what is our vertex? Vertex minus b by 2a is between 1 to 5. Third condition, a into f1, right? A is 1 here. A is 1 already. So it will be f of 1 will be positive. And fourth condition, f of 5 will be also positive. We solve all four and take their intersection. You see, as it is, they have asked without any twisting, turning of concepts. It is as it is asked. Remember all those conditions, guys. Okay. So this is it. Just solve these four. You will get your answer. Next one is also similar. Consider the quadratic equation. Let us be set of interval for which one root of the equation lies in 1, 0, 2, 2 to 3. That's all. F of 0 into f of 2 is less than 0. And f of 2 into f of 3 less than 0. That's all. You solve these two and take their intersection. Nothing else. Solve these two, take the intersection because it is as it is asked. Right? Do you see the language? Do you see the language of problem? One root between k1, k2, other between k2 and k3. Exactly same thing. See how simple these problems are. Okay. The set of all values of x. Now this one was quite calculative, right? Very, very calculative. The problem is for which the equation has a real root. Now how it is related with location roots? Let me show you. See, when you divide by this plus 2 square, so this equation will look like something like this. 3x square plus 4x plus 3 divided by 3x square plus 4x plus 2 whole square, right? Then minus k plus 1 into 3x square plus 4x plus 3 divided by 3x square plus 4x plus 2 and plus this we have divided by square. So k is equal to 0. So we take this as t. So t square minus k plus 1 into t plus k is 0. This is what we get. And see, we know what is the range of t. See, what is t here? That t is 3x square plus 4x plus 3 divided by 3x square plus 4x plus 2. So in quadratic by quadratic, I have taught you how to find range of this. This will be 1 plus 2 plus 1 divided by 3x square plus 4x plus 2. right? So guys, from here you will definitely can find range of t. Let's say t is somewhere from a to b, right? You get t somewhere between a to b. So now you have a equation, and you know that roots lie between a and b. That's all. This is the sixth condition. Got my point? This will be the sixth condition, that once you find range of t, so this quadratic is in terms of t, and you will know that roots will lie between those two values a and b, because from here we have got range of t. So this was quite lengthy, but asked in like this is not what we expect from JEE mains, but these days they are asking such questions also, and this is a very nice question, guys. Initially we divide by quadratic, we'll make it a quadratic, and then we'll solve for values of t, for which like t whatever range of t we get, we put that for this quadratic. So for this quadratic, t will be between a to b, you use that condition, you will get value of k. Fine. Try it, guys. Okay, so in theory of equation, you have to remember the result for quadratic, cubic, and so on, right? For quadratic, we know, like if we have a quadratic equation, ax square plus bx plus c equal to 0, and let's say roots are alpha beta, right? So what we have, sum of roots minus b by a, and product of roots c by a, right? For quadratic. If it is cubic, like for ax cube plus bx square plus cx plus d equal to 0, for a cubic equation, suppose roots are alpha beta gamma, right? Roots are alpha beta gamma, so what will be sum of roots? Alpha plus beta plus gamma will be equal to minus b by a. Then sum of roots, sum of pair of roots alpha beta, beta gamma, alpha gamma, that will be equal to alpha beta, beta gamma, alpha gamma. What will be that? That will be c by a. And alpha beta into gamma, that will be minus d by a, right? This is the second cubic which we have to do. Then by quadratic also, ax power 4 bx cube cx square dx plus e equal to 0. So if we have a fourth degree equation, now the roots will be something, let's say alpha beta gamma delta, right? So sum of roots sigma alpha, which is sum of roots alpha beta gamma delta minus b by a, right? Then taken 2 at a time will be equal to c by a. Then taken 3 at a time will be equal to minus d by a. Then 4 at a time, alpha beta gamma delta will be e by a. So I hope these results are not something new to you. You might have seen them, you might definitely remember them. Okay, so for a nth degree polynomial, we can generalize. So if I write this for nth degree polynomial, okay, like a n x power n plus a n minus x n minus 1 and so on up to a is equal to 0. If you write this for a nth degree polynomial, let's say that this is having n roots, x minus alpha 1, x minus alpha 2, x minus alpha n. Suppose this is having n roots. So for those n roots, what we can write? Sum of roots sigma alpha 1 will be coefficient of x power n minus 1 divided by n. Then 2 at a time. 2 at a time will be equal to minus minus plus minus 1 square a n minus 2 divided by a n. If we consider 3 at a time, alpha 1, alpha 2, alpha 3, minus 1 to the power 3, right? Minus 1 to the power 3, a n minus 3 divided by a n, where a n minus 3 is what? Coefficient of x power n minus 3, x power n minus 3, right? Okay, so we keep on doing this. So finally, what will be product of roots? Alpha 1, alpha 2, alpha 3, alpha n. Product of roots will be equal to minus 1 to the power that coefficient n, then constant divided by leading coefficient. So these are the results, and especially you need to remember for quadratic, cubic and biquadratic. In biquadratic, guys, there is a special way for this, like writing these all results has a special way. This taken 2 at a time and 3 at a time. See, How you have to remember for this? Alpha beta plus gamma delta plus alpha into beta gamma plus delta is equal. Now this is taken two at a time. What is it? It is C by E, right? And then the second one, this is alpha beta gamma plus delta, then gamma delta alpha plus beta is equal to minus D by A, when you consider 3 at a time. So for fourth degree equation, this result is very, very important, right? Remembering the result in this way is important because what they do, they give you a relation in pair of these alpha, beta, gamma, delta. So that is why I'm saying you have to remember this also. Okay. So let's solve few questions, or before let's see some important points, guys. Let's go through some point now. These most of the points are known to you. The first point, if alpha is the root of the equation, then the polynomial is divisible by x minus alpha is a factor. Obviously, you write that polynomial in product of those factors, so it will be divisible. Every equation of n degree has exactly n roots, and if the equation has more than n roots, it is an identity, right? Third one, if the coefficient of the equation has all real, right? Now this is important. See, if coefficients are all real, only then the roots will be in conjugate pair. Okay, this is possible only if all the coefficients are real. Okay, this has to be mentioned, otherwise the pair system will not work, like for imaginary and for irrational also. Okay, so equation of degree will have odd number of real roots, and equation of even degree will have even number of real roots. Why? Because imaginary roots always occur in pair. So just imagine a cubic equation. If it has 3 roots, so either one real will be possible, right? Then we'll have 2 imaginary because they will be in pair, or all 3 will be real. Now coming to biquadratic, it has 4 roots, so it can be all 4 real, or 2 real, 2 imaginary, or 0 real, 4 imaginary, because those imaginary roots will be in pair. Clear? If the coefficient in the equation are all rational, the same thing. If all rational coefficients are there, only then irrational root will be in pair. For alpha plus root beta, we'll have alpha minus root beta. That is mentioned. I have been mentioning this point so many times. Every coefficient has to be rational. Last point, 2 real numbers a and b such that f and b are opposite sign, then there lies one root. Now guys, this we already did in location of root. See, when we write it like this, suppose fa is like this, fb is like this. So here you see, when f of a into f of b is less than 0, definitely one root is there for quadratic. But suppose we are not drawing quadratic, we are drawing a higher degree polynomial. Suppose we have polynomial of this shape. Suppose we have this shape polynomial. Suppose this is a, which is positive, f of a is giving something positive, and let's say this is b, which is giving negative value. So guys, here if you multiply f of fb, this is negative, and how many real roots you see here? Real roots, 1, 2, 3. So there will be 3 real roots, right? In case of quadratic, 1 real root. So what we generalize, that if product is negative, if f of a into f of b is negative, minimum 1 real root will be there between a and b. But nothing can be said for positive, because you can see here, you can see, suppose this is a and this is c. Now between f of a into f of c is positive, and there lies 2 roots. But if I take c here, can I say something? F of a into f of c1 is positive, but there are no real roots. But for negative, we can always give this statement that there will be minimum 1 real root. In case of quadratic, exactly 1. Okay, this point is going to be super helpful in like JEE advanced questions. It's sometimes in JEE mains also, but super helpful in JEE advanced. Okay guys, let's keep moving. So this question here, let's solve it. What is say? 2 roots of the equation are equal in magnitude but opposite in sign. So let's say roots will be alpha, minus alpha, and beta. Then, so what is sum of roots? Alpha minus beta is minus b by e. So it is p. So beta equal to p. So we got the root. So if we have the root, so that root will satisfy the equation. So can we say that f of beta will be equal to 0? So f of p will be 0. Put p here in this entire equation. So p cube minus p cube plus p cube minus r equal to 0. So we get p into q equal to r. P into Q equal to R, C will be correct option, right? We wrote the root as it is, whatever was given, and we simplified it. Moving on, guys. Alpha, beta are the roots of the equation. Then you see, guys, here what is happening. Sum of roots is 0. If sum of roots is 0, so can I say by the property that if A plus B plus C is 0, then A cube, B cube, C cube will be 3ABC. So this will be 3 alpha beta. And what will be this? Alpha square, beta square, gamma square. This will be minus of twice of alpha beta, beta gamma, alpha gamma. So let's put the values. What is alpha beta gamma, guys? This is 3 into minus B minus 2 into what is this? It is A. So it is equal to 3B by 2A. First A is the correct one. Right? Direct result based. Sum of roots was 0, that we got to know and just simplified it. Next one, guys. Would say A and B would be two distinct roots of the equation x cube. The equation which AB has as its root is equal to. Okay. So A and B are two distinct roots of the equation. So guys, what is AB into, so let's say third root is C. What is it? It is plus 1 minus D by A, that is plus 1. So that C value is nothing but 1 upon AB. So C is the root of that equation, right? C will satisfy it. C cube plus 3C square minus 1 equal to 0. And C is equal to 1 upon AB. So we can replace it. So 1 upon AB whole cube plus 3 times 1 upon AB whole square minus 1 equal to 0. So we get a cubic equation minus AB cube, right? Plus 3 times AB plus 1 equal to 0. So let's say AB is x. Let's assume that AB is x. So we get equation x cube minus 3x minus 1 equal to 0. So this is what your answer will be. X cube minus 3x minus 1 equal to 0. Clear? I hope this is clear to you guys. Moving next one, right? I just assume that these roots are A, B and C. So C we got equal to 1 by AB. We substituted it. We got it. Let's solve next one. Okay, so let's talk about transformation root. Now, this particular concept is only helpful for higher degree polynomials. In quadratic, it is not that much, but I'll teach you. See, in this, what we do, like instead of finding the roots, what we do, we transform the equation with the help of combinations. Now, obviously, we will not understand. See, suppose we have a quadratic equation, ax square plus bx plus c equal to 0, whose roots are alpha and beta, right? Now find quadratic whose roots are 1 by alpha, 1 by beta. Now we have the simple logic, right? X square minus sum of roots product. That is fine. That method is very simple. But the transformation thing I want to teach you. See. So suppose my required quadratic is something like this. Ay square plus by plus c equal to 0. Now what is that y? That y should be either 1 by alpha or that y should be equal to 1 by beta, right? Clear? Y should be either 1 by alpha, y should be 1 by beta. So I need to get an equation in y which is satisfying 1 by alpha, 1 by beta thing. Now can I say, you see, in this equation I can say that x is equal to alpha and beta, right? So I can say that y is definitely 1 by x from here. Y is 1 by alpha, y is 1 by beta. So simply I can say y is 1 by x. So what is that x basically? So that x will be 1 by y. Now we know x is satisfying this equation. So you put it here. So this will be a into 1 by y square plus b into 1 by y plus c 0. And c we get the equation cy square plus by plus a equal to 0. And this quadratic has roots. This quadratic has roots as 1 by alpha, 1 by beta. Then you change the variable. Change variable again. It doesn't matter, no. You change the variable, you put it as y, p, q, r, s, t, doesn't matter. Roots will not change. This is the equation y, and y we had assumed 1 by alpha, 1 by beta. So y is equal to 1 by alpha, 1 by beta. Right? So we just change it to x. So cx square plus bx plus a will be 0. We change variable y to x, and the x is 1 by alpha, 1 by beta. So this step is what we know as transformation. This step. This is the transformative step. right? So if you have roots given, you see the what is this transformative step, you apply it into the original equation. From there you derive the new equation and then change the variable. You get the root, you will get the equation with the required roots, right? So for quadratic this doesn't make sense because it's simpler to write x square minus 1 by alpha plus 1 by beta into x plus 1 by alpha into beta, right? Because everything is known. But for cubic, for biquadratic, this is going to be a problem. Okay, so this transformation will help for those. So let's solve a question. See, the question says, now I'll show you like how exactly it is useful. Alpha, beta, gamma roots of this equation. Okay, then find this. Now just imagine calculation, guys. Just imagine calculation. If you started multiplying these all and started calculating, just imagine the calculation. But do you observe one similarity here between the symmetry between roots? You see, x is here, alpha, beta, gamma, right? But if you see these, you will see one more thing here. You see, if I derive a quadratic, cubic, if I can derive a cubic with these three roots, then sum of the roots will be my answer, right? Suppose this is something, suppose it is something, this is some x1, x2, x3. So if I can derive a cubic with roots x1, x2, x3, my job will be done. Okay, the sum of roots will be the coefficient of x square will be my answer, right? So can I say here that if I want a cubic of some this type, ay cube by square plus cy plus d equal to 0, right? If I want a cubic where y is equal to this, where y is equal to 1 plus alpha upon 1 minus alpha, 1 plus beta upon 1 minus beta, 1 plus gamma upon 1 minus gamma, and the sum of roots will be what? Minus b by a. Sum of these three, the sum will be nothing but minus b by a. So I hope you got the point that we will derive an equation in these three roots, and for that we are going to transform that very easily. How? In place of these three, I can simply write that y is 1 plus x upon 1 minus x. You can see y is 1 plus x upon 1 minus x. So multiply it. So y minus yx is equal to 1 plus x, right? So what is x? X is equal to y minus 1 divided by y plus 1. Now x is satisfying that equation, you put it there. So it will be y minus 1 cube divided by y plus 1 cube minus y minus 1 divided by y plus 1 minus 1 equal to 0. And then you cross multiply it. So this is y minus 1 cube minus, this is y minus 1 into y plus 1 whole square, right? Y plus 1 whole square minus y plus 1 cube equal to 0. Now after this, you don't need to simplify it completely. We are interested only in b and a. Now what is b? B is coefficient of y square, a is coefficient of y cube. So minus of coefficient of y square, coefficient of y cube. Just look at the coefficient of y square. So from here what will be having? Like, see, from this term, when you expand it, we are going to have a y square term, right? So let's say what is y cube total coefficient here, total y cube. So here it is 1, here it is minus 1, 0, again 1. So this is minus 1 here. Clear? Y cube, very simple to calculate. Now y square. So here we'll be having 3y square. So minus 3 from here, right? Minus 3. Then from here, this is minus 3, guys, right? Minus 3 y cube minus 3y square, right? So minus 3 from here. What about here? This is y square plus 2y plus 1, right? Y square. So minus 1 minus minus plus 1. This is minus 3 plus 1 minus 2, and this 2y, right? 2y. So this is 2y square, right? 2y square. So this will be this is minus 3 plus 1 minus 2, minus 2 plus 2, again it will become minus 2 minus 2, sorry, minus 2 minus 2 will be minus 4, and from here minus 3, so it will be 7. So it will be minus of 7. The answer will be minus 7. That's all, right? We found out coefficient of y cube, and coefficient of y square, that's all. Or you can simplify it also. But it is obviously less calculative than simplifying this. Or some of you might be think other way, but remember, this is a very useful weapon which can be used in solving different difficult problems. So I hope you understood the transformation approach. Okay, let's solve. Let's start with the last topic for guys today, which is drawing polynomial. Extremely important thing, because so many chapters are dependent on graphical approach, and it is very simple. Drawing polynomial, just few steps. Step 1, find critical point. Find critical point. Now again, what is the critical point? The points where dy by dx is 0. Differentiate y with respect to dy by dx, put it equal to 0. All those points, you plot them on coordinate axis, right? Suppose this is x equal to x1, x2, x3. So you plot on coordinate axis. You plot all those points on coordinate axis. This is the first thing, right? The second thing, step 2. Step 2 is you need to know nature of curve at infinity, right? Find y at x tending to infinity, x tending to minus infinity. And step 3, join extreme points and critical points. That's all. Only these 3 steps are required. Now at critical point, one thing you must understand, see, critical points are corresponding to dy by dx equal to 0. So those will be turning points. Either they will be like this, right? Or they might be like this. So this is the point which is your critical point. Let's say x1 comma 0, or this is x2 comma 0. So critical points are the turning points of the curve. When you are finding critical point, you are basically trying to find turning points of the curve. So first thing, find all those turning points, plot them on coordinate axis. Second thing, get to know the nature of polynomial. If it is like a odd polynomial, it will be always from negative infinity to positive infinity. If it is even polynomial, it will be from positive infinity to positive infinity. Okay, and then just join everything. That's it. And it will be an automatic, it will be intuition that it should be upward or downward. You will see. Let me show you one curve here. So here we have y equal to x cube minus 4x upon 4. So let's find out critical point, differentiate. It will be 3x square minus 4. Right, dy by dx comes out to be, this is, or let me change it, because otherwise calculation will be too huge. Let it be x power 4, guys. X power 4. Let it be x power 4. So now if you differentiate, okay, I am writing again. This is x power 4. Otherwise the calculation will be huge. Let's differentiate. So what is the dy by dx? So x power 4 will be 4x cube. This is minus 4 into 1 divided by 4. So that is x cube minus 1. X cube minus 1, right? So if you put it equal to 0, you get only 1. You get x equal to 1. So you have only one turning point. The number of critical point will tell you how many critical points you have. So you have one turning point. So one thing we got to know. So what is it? Plot it. So at x equal to 1, what is y? At x equal to 1, y will be 1 minus 4 minus 3 by 4. Right? Put 1 here, 1 minus 4 minus 3 by 4. So plot 1 comma minus 3 by 4. So 1 comma minus 3 by 4 will be something here. Let's say this is 1 comma minus 3 by 4, right? That is done. Second thing, we need to understand the nature at extreme ends. This is by even degree. This is a thumb rule, guys. If leading coefficient is positive and we are having a even degree polynomial, it will start at infinity, it will finish at infinity. Like you can see, if you put x equal to infinity here, since this is x power 4, so infinity power 4, it will start at infinity, it will finish at infinity. Right? Because if you put x power, x is plus infinity, infinity power 4, very large positive. If you put x as negative infinity, minus infinity power 4, again very large positive. It will start at infinity, it will finish at infinity. Next thing, what we know? we have critical point x equal to 1. That is all we needed. After that, we just join those extremes to those points such that we have to show that it is having a turning point at that critical point. Okay, at 0, what is it? At 0 it is 0. So guys, this is how it will look like. This is something like this. Turning point. That's all. That's all. It will start from negative infinity. You can see at x equal to 0. If you put x equal to 0, y will be also 0. That's it. That's it. And see, it is intersecting twice. Right? You see, it is intersecting twice here and here. And those are the two real roots. From this graph, we can say this is having two real roots. That's all. Because it is intersecting twice. That's all. Critical point. Second thing, you need to understand the nature at both infinities, at negative and positive, and just join them. You will have your self-intuition if it is like this or like that. Let's solve one more, guys. So it is x power 4 minus 2x square plus 5. So what is dy by dx? Again, we have a biquadratic. So this is 4x cube minus 4x. So 4 into x into x minus 1x plus 1. This time we have three critical points, right? If you take x common, this is x square minus x. So we have three critical points, right? So what is at 0? At x equal to 0, what is y? 5. At x equal to 1, guys, y will be 1 minus 2 minus 1, 4. And at x equal to minus 1, y will be again also 4. So we got these critical points, turning points. Let's join them. Also, this is an even degree polynomial, right? So if you put minus infinity here, there will be positive infinity. When you are dealing with a polynomial, ignore all the terms. You have to discuss, or you have to deal only with the highest degree term when talking about infinites. No need to go for low degree, only the highest degree term. X power 4 will tell you what is the nature at infinity and negative infinity. If it is a cubic, x cube, x cube will tell you what is the nature at infinity, negative infinity. So this is positive x power 4. So it will start with infinity, end with infinity. Let's join all the points here on coordinate axis. So at 0, y is 5. So fine. 0, 5. Let's say this is 0, 5. Then we have 1, 4 minus 1, 4. Let's say this is minus 1, 4. And then we have 1, 4. So we got all these, right? We got all the things. And what did I tell you? Self-intuition will be there joining that if it is having turning point upward or downward, you see, it has to start from here. It will be start from here. Then turning point. Again a turning point. Again a turning point. That is all. That is all, guys. You see how easy it is to draw these polynomials. And why it is important to understand drawing, because in exam you will have questions. Suppose in the same graph, if they give you this thing, that if x power 4 minus 2x square plus 5 equal to k, suppose this is given, and it says that it has 4 solution, or let's say has 4 solution. Find k. Find k. So we know that when we solve problems like these, okay, in previous classes also I told you that when fx equal to gx, if we have to count only number of solution, then we draw their graph and we count intersection. So like in this graph, you can see between this, you see, if I draw a line here, it is intersecting 1, 2, 3, 4. So if I choose any k between 4 to 5, if I say that k belongs to 4 to 5, it will have always 4 solution. How? You see, they will intersect 4 times. You see, 1, 2, 3, 4. Always 4 intersection. Right. But if you see, if you don't have idea of graph, you cannot solve problems like these. And JEE Main has also asked, Advanced has always asked on this. So this is important. Draw the graph. If that polynomial is equated to some constant, it's like just drawing y equal to k. You draw LHS, RHS, and find out number of intersection. I hope it is clear. Okay. So this is homework for you. This is a homework. Okay, find k, if it draw it and see how many times it is intersecting. Like in the previous problem, if I say find k if there are two solutions. So you can clearly see that if I draw this line, if I draw any k greater than 5, it will intersect twice, right? For 4 solution, 2 solution, then k will belong for where? 5 greater than 5 to infinity. If I say 3 solution, if I want 3 solution of this equation, guys, if I want 3 solution of this equation, there is exactly 1 point where I'll get k equal to 5 to infinity, and union, guys, for this 4 also, right? Union 4, because at 4 also you can see, if you draw a line, it will touch at these points. So for 3 solution, I hope you can see that particular space. This is it. 1 here, 2 and 3. So for 3 solutions, k has to be exactly equal to 5. Okay, so I hope the funda is clear. So this is homework for you. And guys, that's all for this lecture. See, many problems I have left calculation up to you, because this is what I assume, that if you have understood the question, the calculation part is yours. Pause the video, calculate it, and then proceed to next question. Okay, I have tried to cover everything. In fact, I have covered 30% extra what is required in JEE Main. So I hope, but I've kept questions very simple. So I hope you have understood everything about today, and you will like this session. And if you have any doubts, do let me in the comment section. Next lecture, we are going to come up with trigonometry. Till then, keep studying. All the best.